So I guess this is Doug Yang, on the topic of access control, traceability, but also access, general access to information, anonymity, sort of not assuring that we're not going to be in some police state in the future. How do we juggle all these
Yeah,
different issues?
it's a good question, Doug. Two things occur to me. The first one is that for general access to information, searching, for example, you shouldn't have to identify yourself um, to access public information, essentially. On the other hand, if there's information for which there is access control, then identifying yourself is an understandable requirement. So I don't think that that those are necessarily in conflict. You should be able to get access to public services without identifying yourself, unless the service has to know who you are. For example, if you wanted to pay your taxes, the system needs to know who you are in order to figure out which tax to present you with, or to whom to give credit for having paid a tax, for example. So did you see those in conflict with each other?
I think they could be, not for the intended case, but the unintended consequences. Traceability, for example, you could argue phone numbers have been around for a long time, and they were intended in some way to know who the two parties were. Now, there's all
Bro,
kinds of
why are you lying,
exploits.
bro?
It sounds like we're getting another Zoom bomb, doesn't it?
Yeah,
Or
it
at
does.
least I'm hearing a lot of
Let
background.
kick
Wow.
off a Todd. I don't know him.
So, Doug, just coming back to your point, assuming you're still there, your concern is that you might be identifiable by a variety of means. For example, if you were coming in from your mobile, maybe your phone number is visible to the system that you're querying. Is that an example?
Yeah, or there's cookies. A lot of this today use cookies or something like that, or IP addresses. For example, all the search engines have some way of tracking these who ask, and then.
So to give you an example, there's an effort here to avoid third-party cookies entirely, to block them, and only to permit first-party cookies, which isn't a total solution, but it gets closer to where I think you want to go. And you're just raising the point, I think, is also valuable. Just to make the point visible that people should not have to be identifiable in order to get public information is an important position to take. So I'm glad that you brought that up. So are there other questions or points that people would like to make?
I had a question. Thank you very much for the presentation, insights. Well, my question is about more basic kind of security threats that we see with just fundamentally BGP with routing. You showed the picture of the internet, but keep hearing about the authorization of origin type of attacks. How do we deal with this brownfield backbone security for something like BGP, given that the internet has already implemented routing policies globally?
So several things. First of all, you're familiar with RPKI, presumably, and there's a strong movement towards implementing RPKI and also BGPsec. If you're familiar with the Manners effort, I would urge you to add your voice to people who are saying we should all get together and implement that. capability in the system. It also wouldn't hurt for us to implement IPv6, but that's a different problem. It's not so much security as much as it is just address space. But it's very clear that the places where we need to encourage that implementation are maybe the places where there's less capacity to do it, just out of lack of knowledge. And so one of the things that I have been advocating is to go to the various network operators groups, of which there are many, as you probably know. One of them here in my part of the world is called NANOG, the North American Network Operators Group, but there are others. Those are good places to go for tutorials and for encouraging implementation. And I would even make the argument that we should create incentives for that kind of implementation to be done. And here's an example of an incentive. If a sufficient number of buyers of service insist that the service include, for example, BGPsec or RPKI, and they won't buy it without it, that can create some incentive. And governments are in a position to do that, among others. So I would certainly urge all incentives that we can introduce to get the infrastructure to be more protected would be useful. So thank you for bringing it up.
Thank you.
Did that sound like somebody was brushing their teeth? This has got to be one of the most interesting conference calls I've had in a long time.
Well, shapes into that, yes, shaping into that.
Well, we're supposed to be edge computing experts, but we're glad to contribute.
Hey, edge computing is actually, let's talk about that for a second, because we've gotten very excited about the fact that in addition to things at the edge of the net, the devices and so on, in the core, where the data centers are, that we can export computing closer to the edge in order to reduce the demand for either computing in the data centers or data transfer across the network. And so local capability is turning out to be really interesting, especially as the IoT space starts to fill out with increasing numbers of devices that are at the far edge and have very modest capabilities, light bulbs and appliances of all kinds. So protecting those things turns out to be very important, and edge computing can be a part of that. Also, on the scientific side, I spend a lot of time with NASA, and there's been considerable interest in the ability to place at the literally the far edges of the interplanetary network, the ability to analyze data so that we don't have to send all of it back, that we can do local computation and local analysis and machine learning and things of that kind at the edge. And so the ability to place these things in an advantageous position is becoming increasingly attractive. And when we start seeing new hardware capabilities, like in our case, the TPU capabilities for doing machine learning, there's a lot you can place in that edge location. I'm actually very interested, Oleg, in knowing what your interests are in edge computing and what applications you're pursuing.
Yeah, so my day job is at Equinix, who is providing the infrastructure for internet peering and private interconnection, and we consider the edge, having presence in multiple kind of locations. One of them is that current internet, distributed internet, is already the edge, right? And the ability to push compute and more specifically, orchestratable compute. In other words, the ones that you don't have to, wheel the racks and, build from scratch, the one that is already pre-positioned and can be activated and connected into the network with the options for private networking for secure BGP. That's really the enabling infrastructure for that. there are many questions regarding the viability or basically, economical viability of a significantly distributed edge, which will have to be solved. But we see a sort of confluence between that infrastructure drivers, application drivers, and network capabilities that yesterday we saw the talk from Meta and how the latencies that we think of normal today, like node 100 milliseconds will shrink in order to provide for that more ubiquitous immersive experience. And edge is going to be obviously needed there. But we still, from the practical perspective, have a lot of open questions on the infrastructure, the physical infrastructure requirements, the fiber, power, cooling, all these things that actually make up the edge in order for the applications to run. So, right now it appears to be a catch-22. Yet we're still in a chicken and egg kind of conundrum.
Well, let's hope we don't lay an egg, so to speak. One thing that I believe we ought to talk about is the speed of light delay, because no matter how much stuff you put at the edge, we can put CDNs, we can reduce the latency to get access to large amounts of popular information, whether it's streaming videos or web pages and things like that. And so companies like Akamai and Google and others are capable of supporting that kind of local access in order to reduce load and latency. But if it's an interactive thing and you're thousands of miles away, there is still a speed of light problem that's going to show up no matter what. So you might say, well, okay, so why don't we double the speed of light? And of course, everybody, Mr. Einstein will tell, Professor Einstein will tell us, can't do that. However, it turns out that you can increase the speed of light by moving out of glass and into atmosphere. And so there is an effort going on, two efforts that would address this. One of them is lasers that just go through the air. Could be up to satellites like the LEO satellite systems. And we know that Mr. Musk is busy looking at the inter-satellite lasers as well as satellite to ground lasers. So that's one possibility to reduce latency. But there's another one, and that's to build fiber that is hollow in the middle. And there's work going on at the University of Southampton where erbium doped fiber was invented that reduced the need for repeaters. They're now looking at and building hollow core fiber, which increases the speed of light in the atmosphere, in the hollow core by about 50%. So it's not doubling the speed of light, but it does reduce latency.
Thank you. Yeah, these are, we're still grappling with, even with the existing, cellular transmissions, right? It's not the speed of the speed of light in the air that's limiting. It's the scheduling algorithms that after that happens, you have to do time slots and user transmission allocations that basically negate any benefits of cutting down on the air transmission. And that, I think, is where the private networks, the free space optics, all that direct communication may help in conjunction with the edge distribution.
So there are two pieces that I think of right away. Your point about 5G and 6G, whatever that is going to turn out to be, versus Wi-Fi and the medium access method and so on, can make quite a difference in terms of being scheduled onto the medium. The other thing that occurs to me, though, is at Google anyway, we're eager to move people from wherever they get access to the internet onto our global backbone network as quickly as we can, because the global backbone network is running at 400 gigabits a second or more. And so at least transmission delay is minimized by quickly getting from wherever you are, whatever access method you had, onto a major transport backbone. So one thing you mentioned the working at the edge in order to deal with some of these very interactive kinds of things. And I can sort of see the gaming, a person playing against a computer game could be very low latency if it's just you and the computer that are interacting. But if it's a multi-party interaction like the one that we're having right now, reducing latency is hard. Even setting aside the one that you pointed out, which is the getting access to the medium itself, but the absolute latency of light is still introduces a problem for synchronization.
Thank you. I think Ike has a question.
Yeah, thank you. Vint, thank you. I just would like to, I'm curious a little bit about your opinion about the subject. I mean, it's a very important subject, but I'm just wondering a little bit, is it, of course, there are major issues with the security, authentication, authorization, but at the essence, and as you mentioned, there are tools that are actually missing certain, let's say, capabilities or functionalities that probably lead to such security breaches. But at the essence, is it really a matter of technical knowledge and competence and expertise? Because I believe they're extremely skillful and competent people on the security. But from the commercial point of view, if you look at the last one and a half decade on the compromises made on the privacy, on business models that actually are focusing not so much on the users, but harvesting privacy data. And suddenly it is not the users, it is not the service that should be up and running and being secure, but indirectly, very much the advertisements that would be actually targeting these people that are the source for this personal data in harvesting, and also the open source. The business model behind open source, what was it? It is create a service, generate traffic, identify the loyal ones, monetize. Last year, Red Hat actually issued, a kind of an enterprise open source paper, and security and quality of software was suddenly #1, while efficiency and low cost of ownership of new digitization was suddenly going to #5. So what do you think? Can these reverse business model or business aspects and compromise on demand on privacy, as opening a parenthesis, what Apple did just a couple of months ago, enhancing suddenly the privacy so the users can actually shut down that people can get information about their personal data. But can this compromise on the demands on actually harvesting personal data has some kind of an impact for their actually very low demands on and this reverse business model actually that has led to all these compromises on enhanced security and security breaches?
So we're about to find out the answer to that question, because at Google, we're trying to alter our business model and our mechanisms so that they don't require nearly the degree of precision that we historically attempted to achieve. Which means basically creating cohorts of users of various types, but not identifying them in any individual way at all. So, frankly, we agree that we'd like to see a business model that doesn't require such an intense focus on individuals. I will say, however, that certain of the services actually work better to the extent that you're able to understand what it is the user is trying to do. We get a fairly good clue about what users are trying to do when they're doing search, because they tell us what they're trying to find, and that helps us figure out what ads we might want to show. But that doesn't require us to know anything about that user over the long term. You mentioned I'm sorry, there was something that you mentioned that I wanted to bring up, and now it's gone out of my head, so I can't tell you.
The business model in the open source. It's thank you for the
No,
federated learning of cohorts.
yes, it's open source. And actually, that I wanted to mention something about open source, which is not exactly along what you were raising, but it's a different problem. Some people assume that because it's open source, that all the bugs have been found because they're exposed. And the answer is most of the time people assume everybody else found the bugs, and so none of the bugs get found at all. And so open source may be the riskiest of all software to use, unless you have somebody curating that software with an eye towards tracking those bugs down and getting rid of them, which I guess is why the Red Hat model is kind of an interesting one, where there's a company that actually makes a business out of curating the open source data. And of course, we try to do the same thing with the open source that we offer at Google. That's not the point that you were trying to make, but it made me think of that risk factor of open source as well.
But
Thank you.
this is,
May I ask one more question?
hey, wait a sec. Hold on just a minute.
Sure.
Before you leave that open source, this is Jeff. But how do you trust the programmers in open source? I haven't seen it happen many times, but I know there's at least a couple of cases where one of the contributors was a valued contributor for many years, but his ultimate agenda was to inject some bug or some piece of code that looked good, but actually was something he wanted to use for a wrong purpose at some point. It would explode, to use a word like that, but at some later point it would become. How do you deal with that in the open source model?
Well, once again, we're back to arguing that open source needs scrutiny. And so I've been arguing that we should look at the open source that's in use today, figure out what's the most popular open source stuff, kind of rank order, and then start scrutinizing that stuff for exactly the kinds of time bombs and other things or vulnerabilities that open source might have. So we should reward people, which we do now. I mean, we offer payment for people who report bugs back to us in the open source that we manage. But we need incentives exactly to do what you're saying.
Can I
You
just
only have
one more?
Yeah, go ahead. I have just a couple of minutes left, and then I have a customer that's waiting.
One thing that I would like to share with you is that I think that we are in a very critical time, because all these monetization of personal data can be very critical in case that you actually use context and semantics that is already trying to be implemented in the 5G together with the permission distributed ledgers for execution of smart contracts. Because think, Vint, my data, if I'll take myself as an example, at home, I'm using milk, I'm using coffee, I'm using washing machine. I'm using many things that I'm buying. So what about if you start looking not from a process-centric platform point of view, looking at functions and capabilities, but you start looking from semantics and context, and then you combine all these value chain, but you have to start looking from completely the opposite angle. You have to turn the pyramid upside down, from the point of view of intent-based management, and not look at how, but very much about what. And you partly have this with the YAML APIs that are machine readable APIs. You have a lot of points, a lot of capabilities and features that are out there, but connecting them, very much as Steve Jobs is saying, connecting the dots that are seemingly unconnectable, but all this personal data is already monetized. So what about if you connect from the point of view of the data that people use with all the people involved in the production and transport? Just an idea.
I thank you for that. I'm unfortunately I can't respond because I have another customer waiting literally outside my door.
Sorry,
Uh,
sorry
but
for taking.
no, it's perfectly okay. Maybe we can carry on a conversation later. Tina, let me thank you for inviting me to join you. Certainly an interesting learning experience, if nothing else. And I look forward to learning more about what the company's objectives are.
Yeah.
So let's look forward to that.
Appreciate
Thanks
it.
so much.
We look forward to continue the discussion with you. We have another half annual meeting in September. We can
Okay.
continue. At that time, we'll make sure everybody has access control authorization before they enter the meeting.
Okay, that's great. Take care, everybody. Bye-bye for now.
Thank you,
Thank you.
Wayne. Appreciate. All right.
Thank you. Bye.
Hi, everyone. So our next topic is about the TSC member sharing. Let's see who we have here. This is Tina, and I'm the TSC chair. Well, we have a very interesting and memorable year for the past. I look forward to keep working with you in the new 2022. I see today we have challenge, but we are confident to solve these challenges. So Oleg, next.
Hi everyone, Oleg Berzin. I'm co-chair of the TSC, working with Tina. I think I just wanted to thank Tina for all the work that you've been doing and holding this together, and the contributions for other TSC members and the community in general. I work for Equinix. I think it takes a lot for people to just contribute their time and feel inspired to move our blueprints forward and continue with the effort. And for that, I thank everybody. Like as Tina said, I think we're an open community. We're making progress in multiple areas. We have new blueprints. We're starting to work closer with standards organizations like ETSIMAC, which looks promising and makes a lot of sense for us. And I'm honored to be here and participate in the work. On the fun part, I'm trying to learn Italian and looking for opportunities to practice. So that's just a fun fact. Thank you.
Gracias. Grazie. I'll try to pronounce my Italian. Okay.
Prego.
Okay. Fukano-san here?
Oh, yes.
Yeah. You want to say some words? This is a TSC sharing session.
Okay. Thank you for about cooperating about our blueprint. And in this year, I'd like to enhance blueprint, and also that I would like to propose the new blueprint to achieve the edge several use case. So it is several challenges to achieve the use case. So I'd like to cooperate with the other company members. So thank you for your cooperation in the last year and for the next year.
Yeah, excellent. You are very good at TSC members. Ike? Jim Shi?
Sorry, I just know the
okay.
mic. Yeah, my name is Ike Allison. I'm just trying to help and assist with the documentation reviews within Akraino. I'm undertaking the role as Akraino Documentation Subcommittee TSC Chair. I'm also a member of the TSC. I'm trying to assist from time to time with some aspects related to 5G and IoT and ETSIMAC. Thank you.
Thank you, Ike. Jim Shi? Jeff Brower?
Hi, Tina. Yeah, this is Jeff. I'm CEO of a small edge computing company called Signal Logic. And I firmly believe in that long-established computer science principle that computing must be moved closer to the data. So I think edge computing has a future, although I do think we struggle at times to figure that out. And we're always looking for the killer app, which seems elusive. But as the future goes on, I think it will become more clear.
Excellent. Thank you for helping organizing this meeting. Really appreciate. Commander Ken.
Yeah, hi. Yeah, this is Kemenda. Hello, everyone. So, yeah, I have been working with Akraino since almost 2.5 years. So it has been a long journey, and we have seen like Akraino from starting, and there we have put the there are a lot of new blueprints, a lot of collaboration across other organizations we have seen during this journey. And I'm confident like in future we will like collaborate more with other organization, and we will deliver as a vibrant community. So as we can see, like in our community we have like different domain we are covering, so it is a unique community. So I'm happy to be here, and I will be happy to help others also. And from TSC I see like there is very constructive and positive discussion happened. Like members are like very active, like Ike, Oleg, Jeff, Tina, so Randy. So I see very positive energy in the team, and I hope I will carry on this energy. Thank you, everyone.
Thank you for standing from the beginning, day one till today, and look forward to the many more days. Leah, Baidu, Mark Shen, Tencent, Obato, Dao.
Hi,
Dao. Hi, Dao.
Tina. It's Doug Ng. So basically, I'm trying to do whatever I can to help Tina, which usually is not that much or not enough. Actually, Jane Shen recruited me to Akraino a few years ago. I've been aware of it for much longer. I worked for AT&T in my former life. I now work for a startup, and I'm both an advocate and a skeptic for the edge. A skeptic because I think we're looking for the killer app or killer apps, and how the industry is going to use and afford capabilities. I think it'll evolve. I'm a huge advocate because I think it's going to evolve, and I think maybe the use case is not apparent yet. And I think Akraino is bringing a lot of those use cases, at least giving them some highlights and some capabilities and some framework to hopefully succeed. So I'm looking forward to continuing to work with Tina and the rest of the TSC. Thank you.
Yeah, thank you. I'm running out of battery. Oleg just talked about Randy, AT&T. Can you hear me?
Hey, Tina, I can hear you.
Yeah, sorry, switch the. Okay.
Your screen went dark.
Yeah. Yeah, because it ran out of battery. Peter here. Ricardo, Ron Huang, Kura from Intel, Sukta, Churchin, Liu Li, Tina, I talked about that, Xinhui, Yanjing. Yeah, it's there either like Sukta in under the weather, and the other people may be too late in China. Speaking of time, we have Zhenhui Shen from Alibaba. Thank you for staying late. He's going to talk about building innovative solution on edge with Alibaba Cloud. Now the floor is yours. Zhenhui, you here?
Yes, I'm here. Can you hear me, Tina?
Yes, I can. Hi, I can see you.
Okay, you can see me now. Okay, it's strange. I cannot see my own videos on my screen.
Yeah, I think you need to. We can
oh,
see.
It doesn't matter as long as you can see me. It's okay. So we run a little behind the schedule. So let me try to start my talk. But before let me try to configure my system settings to allow the sharing of my screen. Let me see. Okay. Bear with me for a second. So can you see my slide?
No.
Not yet. Okay. Let me try to adjust my screen sharing. Bear with me. Well, it's been a long day for us, so, but I think I can still think clearly. Let me see. So what's the wrong with that? This is Zoom. Okay. Apologize for the delay. I don't know what's wrong with my screen sharing here. Because when we experiment before the meeting, it works. Screen sharing. Okay, so let me try to do another way.
That's the first rule of software bugs. It always works when you're practicing, but not when you really need it.
Okay. Yeah, that's true. It happens a lot to those conference demos where we run into accidents. Please grant browser access to screen recording. Then more. Still seems like a permission thing. Well, I apologize. In order not to waste other people's time, Tina, do you think you can change the order a little bit? Let the second speaker take over, and while I'm trying to figure out what's wrong with my computer setup.
Okay. Thank you for being flexible. Okay. I don't know. New Rick, are you here already?
Yeah, can you hear me?
Is that okay? We let you talk. Switch
Okay.
spot with Jinhui.
Definitely.
Yeah.
So
Thank you, New Rick.
Okay.
So New Rick is talking from Etsy ZSM VC, and she's the head of management virtualization and application enablement standardization at Nokia. Thank you, New Rick.
Okay, thank you for the introduction, and also thank you for the opportunity to present here in Akraino. I heard before about Etsy Mac and alignment with Etsy Mac. I don't know if you know that I was one of the founding members that actually initiated the Etsy Mac work in Etsy, and I was the chair of the group in the first term. And for me, it's a big pleasure to see that this is now taken to the next step with Akraino open source. So this is really great. But now let's focus on what I'm here today. Can you confirm that you see the slides?
Yes.
Yes, I can.
Okay, great, excellent. Okay, so today I would like to present the work that we are doing in Etsy in Zero Touch Network and Service Management. And oops, I think I brought the wrong slide set. 1 minute, I'm sorry for that. I apologize, 1 minute. I'm really sorry for that, but this will be fixed in a minute. Okay. I'm sorry for that. So let me bring it again. And today what I would like to do is really to present the work that we are doing and the motivation around this and the areas for collaboration. So we're talking here about unlocking 5G and beyond business opportunities with zero-touch network and service automation. I'm serving also as the ETSI ZSM Vice Chair, and I would like to start with the market needs. A full end-to-end automation of network and service management has become an urgent necessity to deliver services with agility and speed and ensure the economic sustainability of the very diverse services offered by the digital service providers, each of them that has extreme requirements. And simplification is key. We have also to remember that 5G and beyond brings a lot of technology disruptions which bring more complexity, and automation is something that really needs to solve all of this. And the ultimate target is to achieve the highest degree of automation, ideally 100%, and enable network autonomous operation, which is driven by high-level policies, by high-level business targets. The intelligent system will be able to self-manage and self-organize, meaning self-configuration, self-healing, self-assurance, self-optimization without the human intervention beyond the initial transmission of the intent and the business needs. But realizing this vision really requires a new thinking, a new end-to-end architecture framework and enablers which are designed for closed-loop automation and optimized for data-driven artificial intelligence algorithms. So what is our mission at ZSM? Our mission is to define a future-proof end-to-end operable framework, solutions, and end-to-end solutions, and key automation technologies to enable agile, efficient, and qualitative management and automation of the emerging future network and services. And we're not working to create everything from scratch. A lot of good work is done in the industry by different organizations. We analyze and we leverage as much as we can, and we are driving for harmonization and for leverage of synergy. So we actually aim to facilitate this collaboration in the industry and to ensure alignment, leverage of synergies such that the automated end-to-end network and service management can be achieved. We also want to demonstrate the viability of the technology via POCs and to feed back the information into the specific and the learnings into the specification work. And we believe that coordination between key ETSI and external standardization group and open source projects is key for the success. Just a little bit of a background about the group. So the group was formed end of 2017 for a 2 years period with 17 founding members, with a few, I believe it was 5 service providers, operators, and all the major vendors and technology providers. The second term started in 2020 already with 67 members, including 19 operators. And the third term started this year in January. And now we are actually 76 members and 21, including 21 operators. So this is the list. You see it's a very, very diverse list with players that represent the different players in the value chain. A little bit about the industry landscape for network and service automation. So this is a very abstractive and illustrative, of course, diagram, which actually look into the domain managed resources, which may be physical, virtualized, or containerized, the transport network, and then the management domains, for example, which are delineated, for example, by the technology, for example, the RAN access, the radio access domain management, the transport domain management, core domain management, and the responsibility of the domain management is to orchestrate the resources, to enforce the SLA, and the assurance of the domain-wide services. It actually takes and interprets and translates high-level parameters for SLA into domain-level resources, and also make the decision about the placement of the network functions, the virtualized or containerized one. And if we go to the end-to-end level, the end-to-end service orchestration and in automation. So here we have actually the responsibility to orchestrate and and enforce and ensure the SLA of the end-to-end services or end-to-end slices, to decompose the high-level parameters into parameters that are specific to the domain and allocate the SLA budget to the domains. And it has an abstract view on the domains, services, and the sub-slices. And then we have also, when we look at the end-to-end in the landscape, we want also to understand where is the framework defined, what are the key automation technologies that we believe needs to be adapted and used by the different domains in the different organizations, and in order to ensure consistency, coherent operation across domain, across the planes, across sectors, etc. And also about the security framework. So if we look a little bit about how this is handled in the industry, we can understand that this is a complementary effort. It's not that one place is doing all, so it's a complementary effort to enable the end-to-end automation. So if we look at the end-to-end service operation, the cross-domain, CZSM provide the end-to-end solutions for the service orchestration, for the network slicing. It actually takes the templates which are defined in GSMA and provides the SLA assurance, the SLA enforcement. It utilizes some Teamform APIs, some of the C5 service management services. And if we look at the management domain, we have the run management domain is handled mostly by 3GPP C5 and the O1 Alliance. The core domain is mainly handled by the 3GPP C5, the transport mostly by ITF. Of course, we have also MEF, BBF, also the optical levels. And from the perspective of the end-to-end framework, the key automation technologies and the security framework, we believe that ZSM plays the role here. So a little bit about the ZSM architecture. The ZSM architecture was actually utilizing modern technologies, very much based on the cloud native and service definition. It is an architecture which is modular, flexible, scalable, and extensible service-based architecture. So you can see that we have the different management domains. These management domains may be delineated by, for example, the technology domain run transport core, or by organizational boundaries. And we support the separation of domains. So we have the different management domains and we have the end-to-end. And the idea to do that is, first of all, to allow resources in multiple domains to be managed separately, but also to abstract the complexity of the technology specific that brings into the story. And then, for example, each domain just abstract the information towards other domains and towards the end-to-end service management domain. Now, the architecture is based on service-based, so each domain exposed service capabilities. These services are actually just logical grouping. Of course, everything is flat. We support open, model-driven, intent-based interfaces. The domain exposed services, which are supporting data collection, support analytics services, intelligence services, orchestration that can orchestrate multiple resources to form the domain-wide service, and also control particular resources. And this can form, for example, a closed loop automation by closing the loop between the assurance and the fulfillment processes. You can see that all the services are exposed via the data domain integration fabric through the cross-domain integration fabric, and can be accessed by any authorized entity, either by other domains or by the end-to-end service management domain, or directly by the consumer. The consumer of the ZSM framework can be a digital storefront, it can be BSS or OSS processes, or it can be also third-party applications, or even enterprises ones, or even a human being. As I said, the architecture enables adaptive closed-loop management at various levels. There's the driver of automation, and the automated decision-making mechanisms are bounded by rules and policies. We support also shared data lake or whatever stored stream as the lifeblood of the automation, and we support data services and the stateless management applications. The whole architecture framework is designed for resilience and for functional abstraction, and it enables flexible deployment options, and it's open for evolution. So as I said, it can be random domain, it can be transport domain, it can be core domain, it can also be cloud domain, and we can compose multiple domains together to form another domain. Also the end-to-end service management domain expose services to collect the data from the different domains, to analyze the data, to provide some intelligent decisions, and to trigger some orchestration activities. It doesn't have control services because it doesn't have direct access to the resources, but via the different management domain. The architecture, as I said before, enable automation based on a closed loop. So if we look at the different services that we actually expose, and by the way, we have much more services, but these are the key ones that I wanted to show in order to indicate how a closed loop automation is enabled. So we have the observation. This is, for example, the ODA model, using the ODA model. So we have the observe state where we collect the data. We use the data collection services to monitor the managed entities, the resources and the services, and we provide live performance and for data to support the closed loop automation. And then this is used for orientation, where the analytic services provide specific insight, which is based on the data, which is coming either from the data collection services or from the data services, and can actually trigger some actions. Can trigger some insight, provide some insight into the intelligence processes, which actually make the decision and trigger some actions to the orchestration and the control services, and this is actually where they actually act upon. In the following specification, this is the architecture framework is actually specified in ZSM 002. You have the link here. I will share the slides later. And the follow-up specifications for the closed loop automation are actually the series of ZSM 009-1-2 and -3. I will focus on that in a few minutes. Another thing that we are doing in ZSM is actually to provide the end-to-end service lifecycle management. And as we said before, the framework separates the concern of the end-to-end service management and the domain management. It looks how the end-to-end service management and domain management interwork during the end-to-end service lifecycle, and it defines the end-to-end service lifecycle management processes. It analyzes the northbound interfaces or APIs that are provided by the different technology domains, and it documents a mapping of the ZSM services to technology domain NBIs, as well as remaining and identifying remaining gaps. So if we look at the processes of the end-to-end service lifecycle management, so first of all, we start with the service design, but this is out of scope of, or beyond the scope of the document. So we start with the service onboarding, where we actually support the importing of the services or service models into the ZSM framework and creating instances of these services. We have the fulfillment services, which support the management of the lifecycle of the service instances, including their instantiation, activation, deactivation, and decomposing. And we have the assurance processes that assure that the end-to-end service instance is free of issues and meets the service level agreement. And assurance setup and teardown is part of the lifecycle management. The processes consume management services from the different management domains, which are exposed by, for example, as we will see in the next slide, for example, by SwitchGPP for the run management, by BBF or ITF for the transport of fixed access. For the core domain, we have the SwitchGPP, and from the cloud domain, we could have, for example, from Etsimano, we could have Akraino, if this is an edge cloud, Kubernetes, if this is containerized or whatever, and then these are used by the end-to-end service management domain. So the end-to-end service lifecycle management processes are modeled using the ZSM management services, which are mapped to the northbound API interfaces, which are provided by the different technology domains that altogether address the cross-domain interoperability aspect. And then I would like to touch a little bit the key automation technologies. So we start with the closed loop automation, which we highly introduced before. So we have a series of 3 documents. One of them is ZSM 009-1, which talk about enablers of closed loop. We have ZSM 009-2, which talks about particular solutions. It takes multiple solutions and use cases and indicate how the different enablers are used or should be used to enable the solution. And then we have the study, which is DSM 009-3, which look into advanced topic, and this is work in progress. This is published. This is now ready for approval, and this is now still a work in progress. So if we look at the closed loop automation that we discussed yesterday, so what we do in the enablers, we provide governance services that allow the creation, execution, and lifecycle management of closed loop, as well as configuration of related policies and rules to steer the behavior. And it supports also interaction between closed loop and human operators to allow them to supervise the operation and performance of closed loop and allow us gradual transformation towards the full automation and to increase the trust. And then if we go to closed loop to understand how this works within the ZSM framework, so it's clear that closed loop operation can happen in the management domain. By the way, we can have multiple closed loop in the management domain. It can happen in the end-to-end service management domain, and it can span across multiple management domains. So it can happen within the management domain, across the management domains, and in the end-to-end service management domain. And by the way, also beyond the ZSM framework, also in the business level. So what multiple closed loop can run simultaneously, and what ZSM provides is means to coordinate, to delegate and escalate between closed loop, as well as the way to steer the behavior. And it defines the new services which relate to the governance and to the coordination. And that is why we believe that it's very, very important that different organizations leverage the enablers and ensure that we have coherent operation to ensure that, for example, what is happening in ORAN and SD5 in ZSM can coordinate the closed loop and ensure that we have coherent operation, that we don't have risk condition, and that we ensure that we create really a good automated solutions. So if we just a little bit to understand what is the delegation and escalation and cooperation. So if, for example, I have the closed loop end-to-end domain, it can delegate some of the tasks to a particular domain or one or more domains by setting the policies and the intent in the way that to allow them to operate and act autonomously. If they don't manage to achieve the goals, they can escalate it to the end-to-end domain or to the one that they actually provided them, delegated it to them. And then if we have closed loop that are working in the same domain or across domain, they can actually work to cooperate together in order to achieve together the overall goal. Intent is another key automation technology. We're working on that in ZSM 11, and this aims to specify what is expected from the system to achieve instead of rather than providing instructions how to do that. It is a very hot topic in many SDOs and open source projects, and it's highly, highly important that we are driving for harmonization across the industry. I believe that providing intent to the network, they don't care. No one cares if this is the edge or this is RAN or this is a core or this is end-to-end. They want the same practices how to do that and how to provide the intent. The ZSM work focuses on intent as a key enabler for autonomous networks. It focuses on the end-to-end aspect, and it also focuses on how to handle the conflicts. The expected outcome of this study would be recommendations on needed capabilities, interfaces, how to do the lifecycle management of the intent handling, the inventory, the knowledge management. The publication is planned Q1 2022, and we hope to have it as a basis for the new normative specification that will follow that. We also work on enablers for AI-empowered network and service automation. The motivation here is, first of all, to make it an integral part of an AI integral part of network and service automation. And the question is how to operationalize the technologies into automation management framework and functions. We need to acknowledge that AI technologies integration is still very much manual intensive and case tailored and with very limited automation, portability and reusability, and we need to enable the automation empowered by it. And there are some standardization challenge, how to enable multi-vendor cross-use cases, cross-domain, interoperable, unified AI-based operation. And this is what we are working on. It's important to understand that AI is everywhere. It can go from the very, very end edge at the device itself through the network to the very much central data center. And it can it can also be provided in the control plane. It can also be provided by the different management domains and in the end-to-end management domain. And where to place the application is really depending on the scope of optimization that we need, the business opportunity that we have, and also the preferences, the distribution versus the complexity that distribution brings, the performance that I need to take an action, to take a remediation and actions very, very quick, and that we have a very stringent real-time requirements. There's the complexity that brings the need to coordinate and ensure that we don't have race conditions, and also to understand that as much as we distribute the AI application, we mean that holistically, from overall perspective, it's not necessarily the optimal optimization as it could be if it would be done in a more centralized place that see the overall picture. We need also to ensure that we have a management control data continuum, and we need to see that as a whole. And it is essential to ensure that we have cross-use cases, cross-domain, cross-planes, interoperable, unified, and consistent cognitive operations, AI-empowered cognitive operations. And for that sake, we actually work to specify the enablers, and we hope that the industry will adapt and align with that. So in this document, we are working to specify the key enablers and functionality. We are working to support deployment diversity and multiple deployment options. And we're working to work on the trust and adoption because this is a key barrier for the adoption. So just to mention the enablers, so we have the execution, what are the infrastructure capabilities to support AI application execution requirements and constraints in terms of flexibility and efficiency, that I can run it in every environment, on cloud, on premise, on device, about computing continuum that we need to consider, etc., and also to consider the different deployment options. The next one is the data, and there are a lot of things in the data. Today is tsunami of data, how I can make more intelligent collection of the data to ensure that the data that is needed that can help me with the AI application is really there. How I can enrich the description and the expressiveness of the data, how I can handle the dynamics nature of the data patterns that also change over time, how to govern the data, etc., and how to expose it. The next enabler is the inter-AI, how to enable applications to communicate, to be able to help each other to achieve the AI goals that they have, or the analytic application that they have. And then the next one is the action and how I can trigger the action and how I can express the action and how I can explain the action that I'm taking. And this is where the governance is coming, how to steer the behavior, how to express the result of the machine to increase the level of adoption and level of trust, etc. So a lot of challenges are coming here in the AI enablers, and this is something that we actually expect to complete the document mid of this year. And we hope that this will be, of course, adapted in the industry, by the industry, and used by the different organizations. So what we actually do in the document, we analyze the scenarios and the requirements. We analyze the management services completeness, and we do some gap analysis. And then we specify the enabling areas, definitions and requirements, and we define and specify new management services to support. We are making sure that we support the different scenarios, deployment options, and validate that. And we try to align the terminology also considering what happens in the industry. We want to achieve better management and automation with AI inside, and we want to have better AI with the right management and automation framework capabilities. We want to equip the ZSM framework with capabilities for full AI operations enablement. We want to create compact stage 2 specification, which cover, as he said, requirements, management services, and that it supports the deployment options. The last aspect that I want, and we have more documents, but this is the last document that I want to focus on, is the security aspects. It's very important to realize that the threat surface is very extensive in the ZSM environment, mostly because of the openness nature of the ZSM framework, and also the nature of the emerging technologies like AI/ML, that where you can accelerate a security hole if exists, the data lake, the cloud native applications, and we believe that compromising the security may adversely impact the business of the operators and the vertical service providers. And there's also a need to comply with country, region, industry security laws and regulation. And this is an obligation for the service providers and for their suppliers. So having a native security with adaptive framework, access control, trustworthiness, security assurance, and Bill talked about many of that before, can help to establish confidence and trust as the automated processes deliver the intended business outcomes. Yeah, so what we actually did, we made a study in ZSM 10 where we actually analyzed the security aspects which relate to the ZSM framework and solution. We leverage well-established methodologies. It's a very comprehensive document to identify and analyze the potential threat and assess the related risk. And we propose the mitigation options, the countermeasures and security control to address this. This include, for example, aspects related to trust relationship between multiple management domains and components related to the ZSM framework. I have a typo here, I'm sorry. It relates to the security assurance of management functions services. It relates to the multi-tenancy of the ZSM framework. It relates to the access control for the management services which are provided by the framework. It relates to the security of AI/ML enabled services which are provided by ZSM security. And the outcomes actually, we need, and the outlook is that we need to continuously study the threats because this can enhance and accelerate as we have more and more services and more technology emerging into this space. And what we do next is actually we started, by the way, the study is published. And what we actually do now, we work on the normative specification, where we try to specify the requirements to support the security control. We specify security capabilities as management services. We document deployment aspect of security scenarios to validate the applicability of the security requirements and management services, and related work from standard development organization, open source projects, and other sources will be considered and reused where appropriate in the development of the specification. So, a little bit about the work status. So these are the published documents. There is a link to all of them from the end-to-end architecture and solution or framework and solution. All of this is already published, and the key automation technologies which are published. And this is work in progress. We are going to complete the cross-domain end-to-end service lifecycle management. The closed-loop automation solution is now in final approval. The advanced topic, the intent-driven autonomous networks, we are going to complete the study soon and start the normative work. The enablers, we hope to complete it mid of this year. We started working on CI/CD automation and the normative aspect of the security part. A little bit about adoption and alignment across the industry. So important to highlight that the ZSM architecture was leveraged by GSMA and G.127 end-to-end network slicing and architecture paper. So you can see that this was highly inspired by the ZSM architecture. On up, there was a big effort between the organization to map the components to the ZSM architecture and to see how this can be utilized to support the implementation. 3GPP, SE5, SBMA, service-based management architecture is aligned with our architecture, and SE5 management services are leveraged by our solutions, and ZSM key automation technologies are leveraged by SE5. ORAN, the SMO, the service management and orchestration and non-rhetoric architecture was inspired by the ZSM architecture and principles, and we are working with the ORAN TSC to ensure that we can further enhance the collaboration and the alignment. Team Forum, we actually use many of the Team Forum open APIs. We're studying actually as part of the end-to-end domain. Just an epilogue and to complete my presentation, end-to-end zero-touch network and service automation are essential to unleash the business potential of 5G and beyond. The ZSM framework is versatile and built on service-based principles offering scalability, modularity, extensibility, and flexibility. It supports the transfer of autonomy from the operator to the network using intent-based interfaces. It integrates capabilities for closed-loop operation and coordination in support of the zero-touch operational goal. We always need to remember the goal, and it provides means to integrate AI-based functionalities, enabling operational autonomy. A CSM specified key automation capabilities that we hope that the industry will leverage to ensure that the end-to-end automation can be achieved. The SG is working to ensure safeguarding of the ZSM framework and the automation processes. Alignment and leverage synergies across the industry is essential to enable the orchestration and automation of end-to-end services and ensure adoption at scale and accelerate time to market. I want to highlight that end-to-end automation is a big deal, and it represents the industry next year's journey. We started the plan, actually we already started our third-term work, and what we try to do is to learn also from real deployments and from POCs and to feed the information into the standardization work. I want to highlight that the ISD, the industry specification group, is open for both ETSI member and non-ETSI member, and we're inviting you to join us and help advancing the technology and also to help us to demonstrate this proof of concept. As now I'm talking to the Akraino community, I also want to invite you to cooperate with us and jointly help to accelerate the adoption, to integrate the Akraino solutions in the end-to-end solution, and to demonstrate the viability of the technology. A little bit of more information you can find in the last slide, the blogs that actually describe what we achieved, the technology page, the wiki with the POCs, the published specification, the ongoing draft developments, and all the portal is available here. Thank you.
Yeah, appreciate Nurit. Speaking of time, we'll probably receive only one question. If anyone has a question, comment, Ike, please.
Nurit, thank you so much for the presentation. It's a very challenging topic. I'm a former Ericsson employee. I'm not a technical person. I have a background from sales of turnkey cellular networks end-to-end. Now, what a little bit, I'm missing more, I just would like to share with you. When I look at the GR004, the landscape that you mentioned about, published in January, you have all possible, what shall I say, platforms on management, MEF, as you mentioned, Mac, TM Forum, even, 3GPP with NMS, with consumer and producer. But on the other hand, if we take Diego Lopez, what he's looking with the PDLF, and the execution of smart contracts that will enable you with authorization and authentication and provisioning of subscriptions and units. And also if you take the support in 5G NDL with context and semantics. And also when you look now with the 5G advanced, the next release 18 on the interoperability and roaming between MPNs and SMPNs, PCF will have a key function partly with the default, provisioning server or default configuration server for, in onboarding both the networks and users. But at the end, Nurit, wouldn't be in a way the services that are defined by the architectures, SEAL, VIAPA, and HLT. And we also have different clients already that will be running partly for the edge, with the EEC, or, the application data analytics enablement client, for the VAL, with the verticals, and also for the service function chaining. What confuses me, instead of having a vertical, functional, very much focus on process-centric about how, a little bit going to TM Forum intent-based management about what, with respect to also quality of service fulfillment with the 5QI, where can we find out, of course, SA5 is still struggling with end-to-end API flow and definition, but when can we get a little bit more focus on management of, in a way, semantics and context, and then going, or intent-based management, because you already have the APIs YAML, and then going to the functional part of how do you do, because you still will have eventually 5G will be a network of networks, and all these small networks will be specified for particular services. So when, instead of an SBMA in the 5G is going separation of concerns, but that will be again designed for particular services. So when can we start going more on the management focus from the semantics and context, and moving away from the functional process description, very much as it is silos in the GR004 now from January, but going more to the context and semantics.
Okay, so I will try to address it shortly. And of course, I'm happy to continue the discussion offline, because I understand that there is some time constraints. First of all, considering the fact that you are a sales person, I must say that I'm impressed by the technical knowledge that you just demonstrated. But just to tell you, first of all, ZSM004 was a study that we have done, a survey that we have done to analyze what is happening in the industry and what we could leverage for the ZSM solutions. Okay, so this is not a spec that we are providing or whatever, it is a survey of what is happening in the industry and what we could leverage in order to enhance our solution. Now, regarding the semantic and the intent or whatever, so yeah, this is what we are working on, right? We're working on intent, we're working to enable the intent, and to manage the intent, and to govern the intent. And as I said, this is the ZSM 11 that we're working on, and hopefully we will now finish it and we will start the normative specification. And for me, it's very, very important, as I said, that all the industry will actually follow the same approach and will align on that, because at the end of the day, we don't want to tailor it for a particular domain. We want to have a common approach across the domains, across the industry, across telco and verticals. And this is something that we will work on. And we will hopefully work and have collaboration across the industry with that. Regarding the specific domain, maybe we should take it offline, because this would be a much longer response. Okay, so.
With a pleasure, anytime, Nurit. Thank you so much. Wonderful news that you're working on this intent-based management. Wonderful. I'll be, I'm following, so I'll be waiting eagerly for that.
Yeah, and this is a key. Intent is key also for opening opportunity of monetizing the network, or a network service, a network plus or outcome or service exposure of the services to the enterprises, etc. So intent is actually key, and automation is key, and autonomous network is key, and this is what we are working on. By the way, together with Flexon.
Excellent.
Absolutely, and also use the redefinition of entity as a place, object, and person, and the context related to entity, very much as defined in the any.
Yeah.
Okay.
Yeah. Cool.
Thank you.
Absolutely. Thank you so much, Nurit. Thank you. Wonderful.
Bye-bye.
Mhm. Yeah, let's continue working with at ZSMBC to see how we can collaborate better from the Akraino blueprint or future project point of view. We'll have the at the MEC hackathon where we also welcome the group for from at ZSMBC to join. Mhm. Oh, I mean, BC is vice chair. I mean, the ZSM. Okay, cool. Appreciate. Our next speaker is Zhenhui Shen, the principal product expert of Alibaba Cloud. Thank you for staying late. I think it's almost 1 a.m. at your time. So the floor is yours.
Oh, okay. Okay, thank you, Tina. So this time, can you see my screen?
Yes, finally.
Okay, cool. So hello, everyone. So my name is Zhenhui Shen. I'm the product manager from Alibaba Cloud. So it's a great honor to be invited to give a talk on the Akraino technical group meeting. So my topic today is how to build innovative solutions on edge with Alibaba Cloud. So Alibaba Edge Cloud finds its root in the CDN service. So CDN probably is known to most of you here. Stands for Content Delivery Network. And this network places thousands of servers around the globe to speed up the delivery of web content to end users. So CDN is already an edge network built for special purpose. And back in the year of 2014, Alibaba started commercialization of our internal CDN, which is created for Taobao e-commerce platform. And in the year of 2017, we started building our edge cloud platform. The outcome of that is the release of a PaaS service named Edge Node Service. And from 2019 and onwards, we rolled out gradually a series of applications designed for ENS. So CDN is the first service to be migrated, and new products like VC and the cloud-based X streaming services are launched afterwards. So in terms of the business model, I would say that ENS is offered as a public cloud service. So by public cloud meaning that Alibaba, builds out its own edge network by leasing the resources from carriers' data centers. And starting from 2020, we also, explore the hybrid cloud service. In this model, our customers, they run their own edge network, and we sell software and hardware bundles to them. And we also get paid for the daily operation and maintenance. So speaking about the recognition, Alibaba is considered one of the leading edge computing companies inside China. And we currently have the largest market share, and our massive edge network comprises more than 2,800 nodes distributed around the globe. And over the time, we have accumulated more than 100 patents related to edge cloud. So it is notable that Gartner considers Alibaba Cloud as the main edge cloud vendor. So how is edge cloud compared to other types of cloud? Well, we would say that they are not a replacement of each other. Rather, they stay complementary to one another. So centralized cloud remains ideal for batch processing, which require holding up huge amounts of data at a single location and use powerful machines to do heavy computation. The creation of new cloud types, namely like local cloud and edge cloud, they are driven by real-time computing needs. Examples are autonomous driving, remote monitoring, and cloud gaming. The gist is to move computing and storage capabilities closer to where it is needed. So among the three cloud types, edge cloud provides the widest geo coverage and yields the shortest latency. Today, users from inside China, they can get connected to our edge network from under 15 milliseconds from anywhere inside China. And edge cloud also scales more easily than the rest too. But when it comes to business adoption, people should understand that there are weaknesses and strengths surrounding each cloud type. And only a good understanding of each of those can address all aspects of the digital transformation. And as a matter of fact, Alibaba Cloud provides all 4 types of cloud drawn on this diagram. Okay, finally, I should not leave out on-premise nodes. On-premise nodes actually are special. They are not considered a typical cloud service. Their mission is to help connect thousands of devices to the cloud and facilitate localized data exchange and processing. So this picture here shows the full stack of edge cloud service offered by Alibaba. And we will zoom in and examine the details of a few ENS-enabled applications. So first is CDN on ENS. This is an initiative with the goal to transform CDN network into a general purpose edge cloud. Our goal is to turn CDN processes running on traditional OS into containerized application. The revolutionized CDN is cloud native and exhibits a lot of merits. First, we achieve good customer isolation. By creating virtualized and dedicated CDN subnets and allocate each of them to different tenants, we achieve good customer isolation because damages affecting one subnet will not spread to others. The next benefit is horizontal scaling. The launch of new CDN services on new nodes become much easier now, thanks to the portability of container. And in the past, this is impossible because changing services that run on a node almost requires planning beforehand and deploy static files and executables to these nodes. So we will explain the remaining benefits like cost cutting and improved efficiency while introducing the next application. So the next application is VEC, stands for Visual Edge Computing. So we know that visual computing deals with acquisition and analysis of visual data through the use of computer resources. Examples of visual data are like image and video. VEC actually is visual computing running on the edge. It is a PaaS service to incorporate networking, cloud storage, and AI-assisted image processing. VEC makes it easy to connect streaming devices to the cloud through the nearby edge node. This greatly reduces network latency and largely improves data processing efficiency. The VEC platform can be easily integrated by industry applications through the use of Open API. So does it create a problem if we run VEC along with CDN on the same ENS node? Well, let's look at the resource usage of each service type. CDN mainly uses caching and egress bandwidths. It leaves most computing power idle and much of the ingress bandwidth unused. So this fits VEC's needs very well. So the two applications can actually coexist peacefully on the same ENS node. This is why ENS helps to reduce the infra cost, because we are able to create and run more value-added services using one network and improve resource utilization. So nowadays, cloud-based streaming services are also flourishing. Notable examples are cloud gaming and extreme OTT streaming. With the help of ENS, such services enjoy the benefits of reduced latency and extended use of legacy device. All of us know that streaming services runs complicated computation on the cloud. This spares the need to upgrade terminal device. The rendering result is then transmitted to end user as streaming data. So even legacy device can see extended life cycle to run modern applications. Also, Edge Cloud brings the service closer to our end user. The cut on latency is very vital to interactive applications like cloud gaming. Furthermore, in the gaming industry or in the gaming world, players are assigned to nearby edge nodes. This boosts locality and reduces interference, as down edge node only affects a small portion of players assigned to it. So OTT streaming is another example of thin terminal application. This diagram illustrates the smart home experience created by a Chinese media company called Huashu Media Group. Huashu Group provides cable TV service to many families. By teaming up with Alibaba Group, they revitalized their set-top boxes. Audiences can now control their big screen at home by talking to Timo Genie terminals. Timo Genie is a smart speaker developed by Alibaba Group. It provides intelligent personal assistant service through voice recognition. The two devices get connected through the ENS network. And this is a pure cloud-based software solution. It eliminates the need to replace old set-top boxes and saves a lot of money for Huashu Group. In addition, cloud-based set-top boxes are easier to manage and maintain. This collaboration creates a win-win situation for both parties because Huashu company wins back lost customers. And Timo Genie speaker used to be a consumer-oriented device, but now it starts seeing the adoption by big enterprises as well. So to conclude my talk, I would like to summarize that Edge Cloud represents a new, modern, dynamic, and distributed cloud model. It helps to cut down latency and speed up data processing. It delivers the expected QoS to time-sensitive cloud applications. These applications find their use in industries like media and entertainment, telecom, manufacturing, and logistics. Alibaba Cloud is committed to make Edge Cloud a new and important infrastructure in the era of industrial digitization. So that's all. Thank you for listening.
Excellent. Questions, comments? I have a quick comment. I think a lot of things you talk about, I think it's very, very relevant to what we have been building in Akraino, like the public cloud edge interface. Oleg is the PTL for that. We have been working with most of the top hyperscalers in US. Probably you're interested to join with the other top hyperscalers to build the PSET. Oleg, you have anything to add?
Well, thank you for the presentation. Very interesting, and I guess the public cloud edge interface, as Tina mentioned, is more focused on the orchestrating of resources, the infrastructure, right, for this type of edge and hybrid services, because for an application to function, just like you described, for the application to function in the edge, it is often linked back to the cloud, and in your case, it's a coupled model, right? So basically, I was wondering what type of orchestration capabilities or I guess architecture you employ in your solutions, given that your edge solutions are basically linked back to the cloud and effectively do you manage everything from the cloud, or do you have an autonomous edge that that could be orchestrated independently, or do you worry about these things at all?
So in general, I think what we do is we don't leave the edge unattended by our control panels. So we do create a single management platform to closely monitor the running condition of all edge nodes distributed around the globe. And I think this is what we advocated to our customers, so that no matter where they choose to get onto the cloud through the access point, and no matter where they try to deploy their applications, they can always, closely monitor the running condition of their applications from our central console. And this is what we currently we are doing. And in terms of the autonomy capability you are talking about, I think currently it's not being planned by us.
Yeah, makes sense. Yeah, and the other thing that I noticed, which is I'm speaking after you, so I was gonna kind of touch on that as well, is that with your solution for this set-top box in the cloud, it just represents a scenario where the user edge, right, is actually what used to be at the user prem, right, at the edge of the user network, right, is now in the cloud edge, right? So the edge is shifting, and the terminology is constantly changing because of the functions that used to be like at the very far edge, at the premises or in devices like in the set-top box, are now possible to be implemented in the cloud edge. So thank you for the insights.
Yeah, thank you for the comments and the questions.
Thank you.
Yeah, I will recommend the Ali Cloud team to join the PSET, the public cloud edge interface blueprint for further discussion. And also there is the Android cloud blueprint. And we of course welcome the Ali Cloud team to propose your own new blueprint for, I see there are so many great materials in this presentation. It's very relevant to Akraino.
Yeah, sure, Tina. So I think just contact our marketing team, and Nicholas will receive your message, and we will check out the blueprints forum you just mentioned.
Okay, so Nicholas is Kaka.
Kaka, yes. The same.
Okay.
The same,
All right.
Yeah.
Okay, cool. Thank you. I appreciate it.
Yeah, thank you.
Our next speaker is Oleg. I see Bess here, Cora here. So because in the early morning we have a Zoom bomb, so we will just got disturbed and running a little bit behind. Is that okay with you? So we have Oleg, then Bess, and then Cora. So is it okay for 3 of the speakers?
Yeah.
Okay, cool. Thank you for your flexibility. Then Oleg, floor is yours.
Okay, let me share my screen. All right, so let me see if I can go into the presentation. Okay, can you see the screen in full presentation mode?
Yes.
Okay.
Wait, it's yeah, it looks like, okay.
Okay, thank you. So this presentation is basically, it will talk about the infrastructure drivers for the edge. We'll use an example of 5G for kind of making those sort of representations, as well as it will describe what I think is a very interesting trend in the edge infrastructure enablement, is this DevOps driven and infrastructure as code capability. And I'll talk a little bit about Equinix, the company that I work for, as to what we're doing in supporting both the infrastructure, the application of this infrastructure in 5G, for 5G, for example, and what we do in the infrastructure orchestration. So on this section, so you've seen this, I'm just using this as a sort of the starting point. Jeff showed this a similar slide yesterday, but basically, you know, and as we saw from our speaker, Vince Cerf, in the morning, it's the trend that we're kind of going through from the centralized sort of internet, where the distances between the user and the application on the order of hundreds or 1,000 kilometers, and sort of the latency was on the order of a second, and it's all really kind of been transformed by this peering model, right? So really the ability to scale the internet is to decentralize it as much as possible within the economic kind of constraints, and flatten the traffic patterns where we don't have to really kind of go to the central sort of peering to go back to the edge. And this is what's been happening for years. You know, we have really the infrastructure players around the world, as Vint was showing, establishing the internet exchanges, and, you know, providing capabilities for bilateral and multilateral, you know, private and public peering. Obviously, this raises a number of, this scaled up the internet. This reduced the distances, you know, from user to applications to hundreds of kilometers, and to hundreds of milliseconds, right? So 100 milliseconds would be a very good characterization for what we need as far as the packet latency concerned, when the application client goes to the, for example, a service in the cloud and back for the most kind of connected areas of the world. But what we're seeing now is basically this further distribution to the edge. You know, we have various reasons for that. You know, and, you know, there are still questions, sort of chicken and egg questions, you know, how to enable this infrastructure. I think if we take the various applications that we have today, many of them will sort of, you know, qualify as edge applications, right? But the real question is, who's going to put up, you know, capital behind building out the edge infrastructure, you know, for any of those applications? And I don't think there's a clear answer to that. I think the yesterday's talk from Meta, you know, gives us some insights, and basically the requirements, at least the requirements for the network layer, what we understand in the distances, right, between the user and the applications, are going toward units of kilometers and kind of units of milliseconds, right? And that's really where we're going. I like to make an observation here on this right-hand side of the picture, is that it is the modern kind of edge trend. But if you look at the structure of this, it looks a lot like a plain old telephone network, where the user terminals were the phones, right? You pick up the phone, you get a dial tone within, you know, milliseconds, and then, you know, the central office is within a few kilometers from where you live, right? And that's really kind of like, we're, you know, at a different level, but we're going to a similar scenario. Right. From this perspective, the edge classification, this is really something that we've been trying to think a lot at Equinix about, and you know, this concept of ubiquitous edge, which is something that is present, appearing, or found everywhere, right? And you know, we kind of landed on this latency scale right at the bottom, where we say, okay, so there is a device edge, right? There is what we call, you know, far edge, but, you know, it's really relative to this latency scale. And assuming that this latency is relevant to, for example, a modern access technology like 5G or cable or some optical connectivity, right? You know, this type of access latency is not necessarily just the speed of light on fiber, but, you know, involving scheduling, you know, transmission, encoding, decoding, all that stuff is roughly, you know, for the far edge would lump into like 1 to 5 millisecond access. We then distinguish between this macro edge and micro edge. So the macro edge is something that we think is already very well established. This is what supports the internet today. The example is, for example, Equinix as a company that has on the order of 250, you know, large data center campuses around the world, supporting internet exchange, supporting cloud access, supporting private networking. So that macro edge is already there, right? Obviously, that does not necessarily satisfy the future-looking, latency latency as we saw from Meta. But we think, roughly we're talking about, in some cases, if the users, are located in specific metropolitan areas, that access of the user to this macro edge could be as low as within 10 milliseconds. We actually have done some studies, and we show that for our company, I'll show that later. We have a large percentage of population in the United States and Western Europe, and their associated GDP is within 10 milliseconds of kind of fiber grade access to the data centers, macro edge data centers. We see also this and this macro edge data centers are basically what we call interconnection hubs, peering locations, multi-tenant data centers. Another example, local zones for clouds. This would be a good example. But obviously, we understand that there is a need at some point to move closer to the user, and that's really not necessarily the in between this, on this scale between the device and the cloud, there is a sweet spot for this, what we call micro edge. And the sweet spot is actually defined, we think, by not only the technology and the application requirements, but also economics, real estate, efficiencies, and the ability to aggregate as much as possible in order to kind of contain that economic impact on building something like a ubiquitous edge at all possible edge locations. So we call this micro edge, and we think that this is a very specific area that requires dimensioning and sizing. We have our own opinion on what that might look like, but roughly maps to about 5 to 10 millisecond type of access latency from the users, and obviously the core cloud. So, this micro edge is, the analogy here is central offices, but central office infrastructure for example, plain old telephone network may not necessarily be suitable for supporting additional requirements like power density per rack of equipment, connectivity, expansion, ability to support edge computing and stuff like that. So this is sort of the area that we're looking at. The other comment I want to make, and this is from the previous speaker, is that when we look at the classification, for example, from the Linux Foundation, it's great. I mean, that slide shows the provider edge, user edge, but things are not black and white, right? Because, for example, we saw the example where the user edge, right, can be actually located at in the provider edge territory, right, in somewhere like a either micro data center or edge data center, or even in their switching center, or in the cloud. So that line is really blurring, right, because of the capabilities that that this edge computing provides. So therefore, we kind of think in terms of the latency scale, and this is a representation of this nomenclature. So let me move forward here. Okay, so taking an example of 5G now, right? So it's sort of through the work on kind of defining what the edge use case is, we looked at a number of applications. I mean, there's hundreds of applications that could be qualified as edge applications, as I said, right? But really, it's very hard to determine which, what infrastructure requirements would be to support, or what application would drive the infrastructure itself, right? So on the other hand, if you look at 5G, right, just look at the basic sort of target requirements that the technology is designed for across the top. Like, we're talking about 10 terabits per second area traffic capacity for square kilometer, right? That's very high density. 10 gigabit per second peak data rates per subscriber, or even, as a sort of the run-in type of KPI, but it could go to 20, right? High mobility, density of devices, latency itself, right? So everybody's using this 5 millisecond type of example. So, all of this is, it cannot just, those KPIs and targets are there, but to realize that the technology is not enough. So you have to solve for a number of variables, right? You have to care for spectrum, density of the radio access network, fiber connectivity, dense fiber connectivity, aggregation of that fiber, and sort of compute functionality to support the radio access network, transport network, aggregation where you have major traffic breakout and peering and access to clouds, interconnectivity, all the hardware that needs to be distributed. The applications come later, right, on top of all of this, and then the ecosystems, basically people who provide those applications, provide networks, and companies provide the services, kind of stack up on top, right? But overall, we think that there is new kind of thinking that's required in distributing this infrastructure, right, and enabling optimization of where these things go, right? We've seen talks from Etsy. This is basically targeted on trying to understand how to streamline all of this. Meta would be another example here, this multidimensional puzzle needs to be solved differently because of these requirements. So looking at this, and I apologize for the very busy slide, but I was thinking about, how would I put this kind of evolution of an explosion of use cases and really the infrastructure-centric use cases and services, right, on the evolution of, for example, what we see in transformation of 4G and 5G, right? So roughly speaking, in my mind, I classify this as there is a mature stage, which is basically, virtualization of the infrastructure. This is a major component, right? That feeds later into, as we know, into 5G, into 4G and stuff like that. Then densification of the infrastructure, meaning that now, because we have virtualization and because we have all this, never kind of ending requirement for capacity, for both in terms of speed, in terms of user capacity, we have to go into this densification where we now have things like CRAN, we have multi-access edge computing, right? We have capabilities for coordinated processing. And this densification basically based on 4G network, but added to it with capabilities like CRAN and aggregation, right? It allows for new use cases even on this 4G network, as we know. For example, CDNs and video, small cells that allow for this to work, and that kind of feeds into the first appearance of 5G non-standalone implementations, where we saw first services offered on that, fixed wireless access, first devices, and now we have a commercial, sort of widely deployed 5G non-standalone core that supports this type of use cases. In the next stage of it is what I call next generation. This will continue, and that is reliant on 5G standalone capabilities for further distribution, right? And eventually will support this what has a potential to become basically what everybody's looking for. What's the killer app for 5G? Where now the infrastructure, there is a justification to deploy this type of infrastructure, densified infrastructure with all these new capabilities, right, in order to support things like cloud gaming, AR, VR, self-driving cars, and that Meta looks promising. Just by saying Meta, many things sort of could be lumped into that, but I think everybody agrees to support the aspirational requirements and directional, kind of targets of Meta. This type of infrastructure will have to be enabled. This is an example, and as to why the optimal placement of infrastructure elements and functions is very important. So this is made up, right? So this is not really any kind of specific application. But if you look at, let's say if we look at this desired end-to-end latency of 5 milliseconds. So everybody in like, many references, right? In literature, many references in kind of new requirements kind of settled on this 5 millisecond target for network, right? So, and it wouldn't be untrue, like for example, for meta applications, if you need 30 milliseconds from device to GPU and back, right? This is not an unreasonable scenario, but if you break it down, right? Because there is latency on the air interface, and by the way, I haven't seen any responses to my challenge question on the Akraino TSC as to why there is latency on the air interface, like between the device and the base station, but it exists, right? The hint was today on the discussion with Vint Cerf so this latency, we have those latency constraints on just the access side of it, right? There is some processing within the base station, even in the RRH, right, itself. There is some latency to get across the fiber to the aggregation. There's some latency to process at the baseband side of the G node B here, right? Then core side, traversal of local network. And the point of this example, if you break this down, you don't have too much kind of slack here for the application side, right? In order to support these requirements. Therefore, this optimal placement of these functions, and in many cases co-location, is what is important for basically considering the edge type of deployments at the fundamental infrastructure level in order to support this latency targets and requirements, as an example here. The way we look at this, I think some of you saw this slide as well. It's a little bit busy, but the point here is to show that there is sort of the established macro edge and core, right? So we know these data center facilities, we know where they are, we know how big they are, we know how interconnected they are, we know that they provide services for internet exchanges, enterprise connectivity. More and more enterprises move their data centers into co-location facilities because of the reasons for, there's cost, there is manageability, there is distribution, there is COVID, right? All of that stuff is really, is known very well. And these facilities have established interconnectivity to many clouds at very, very low latency, right? And this is sort of a, very well-known secret, right? So the macro data centers of large interconnection providers are located, in a short distance from major cloud availability zones and regions, right? So, for example, if you deploy your infrastructure in the Equinix data center in Silicon Valley, right, your latency to reach your AWS VPC or Azure or Google will be within under 2 milliseconds round trip, right? This is because how this is all constructed physically. So all of this is very well established. Carriers have access to this, right? So the next question is, what if we actually needed to go to closer to the user in order to realize this latency targets and performance targets and application distribution? What infrastructure would be required, right? And so the question here, 5G happens to be, or cellular network happens to be a very good example, because you could actually quantify or create a model where, given the coverage requirements, the traffic requirements, the spectral efficiencies that would be needed to support user demanded traffic, you can actually figure out what equipment is required to support things like ORAN or CRAN. We saw some slides from Jane Chan yesterday from Mavenir, which is very informative as to what a cabinet would look like in order to support certain cellular requirements. But the point here is that we think it's beneficial to consider this sort of multifunction, multi-tenancy dimension, right? Multifunction means that these type of facilities should be able to support, multi-spectrum options, radio access network aggregation. Packet core breakout is critical because, you don't want to trombone traffic all the way to the core facilities in order to come back to a compute node that's at the edge. insertion of edge compute. So all of that requires basically physical infrastructure, right? And this physical infrastructure has to be designed with the sustainability and expansion and growth sort of capabilities, because you wouldn't want procure real estate only to deploy certain things and then later find out that you need to insert compute nodes and you need more land or more sort of fiber to in order to do this. This should be done very carefully, planned and calculated, and we think linking those facilities to the major interconnection hub, starting at the metro layer, could start forming this ubiquitous, at least at the metro layer, edge architecture. This is an example. We actually did some of the work at Equinix to showcase a concept of the slicing must go on. So everybody talks about network slicing. Network slicing is a very, very attractive feature in 5G. The ability to utilize the same network and capabilities on the UE to actually provide resources and functions for different traffic types and different type of latency profiles on the same physical infrastructure. But one of the observations that we're making is that yes, great, we can do all of this in the mobile network, right? There is standardization. You saw the talks from Etsy, just how this could be enabled in a closed loop model, right? But the point here is that the traffic, there's a couple of points here, right? First one is that the traffic that originates in the mobile network doesn't stop at the back of this UPF, for example, right? It has to go on. And it's important to be able to provide for this slice continuity. And in the current sort of enterprise model that we see, this hybrid multi-cloud connectivity is really a big requirement. So with the addition of 5G, that doesn't change anything, right? So we still have the traffic will need to go to low latency destinations like this here, with the edge compute co-located very close to the provider edge, to the network provider edge. The traffic may need to be hybrid, right? So it may need to have access to even within the same slice to low latency MAC applications, but then to multiple clouds. And it could be just multi-cloud type of hybrid multi-cloud connectivity. So the next point here is that the placement of these traffic functions, right, within the slice is really critical, right? Because you can easily defeat the purpose of this green slice that's created in the radio network by utilizing a distant UPF, right? So the traffic tromboning will be very, very detrimental to this, and therefore placement and activation of these functions, and therefore the ability to activate traffic breakout will be very, very important for anywhere from services like this, enterprise-oriented services. I'm showing here this mobile router, and this is very specific for example, for fixed wireless access at gigabit speeds. Even though it may not necessarily need ultra low latency, but tromboning this traffic back and forth from the carrier location, to where the UPF is, to for example, an interconnect point where all the clouds meet, right, is really very inefficient, right, and that costs money. The ability to activate this service, right, on an edge infrastructure becomes very, very important, and that brings up questions of what it would look like. So, for example, the state of the art today for something like a software-based UPF, right, is a layer cake. So you have your compute, you have your operating system, you have your network, you have your accelerators, you have virtualization of different kinds, and then layers within the virtualization. For example, for Kubernetes or KVM, you support things like DPDK and SRIOV. On top of it, you need to deploy your actual function. You need to provision it. This is not this layer cake is a very involved proposition, and I personally believe that because of that, it kind of impedes the distribution of these functions, because in order to be able to activate this function, going through all that process, with all the variables is very difficult. So there is a new trend that we're actually tracking at Equinix is this little jagged box at the bottom. It says programmable network fabric. So the new capabilities in programmable ASICs today, for example, Tofina, programmable data pipelines, enable sort of the UPF features, for example, right? The actual processing of GTP and then encapsulation, decapsulation, and other things that are required to control it directly on the network fabric, right? There were some examples of very cool startups that do this in this area. And we've tried to kind of show that a slice could be made sort of to continue, or slicing must go on by basically sort of activating the mobile traffic breakout features on a network fabric as we activate layer 2, layer 3 capabilities, and extending those slices to multiple clouds, edge computing, and this sort of the environment that we support in our 5G and edge technology development center. I'll talk about this later, but this is an example of how this infrastructure could be enabled. At this section of the talk, I'll talk about the orchestration of this infrastructure, and this is very, very tightly related to the work in Akraino, public cloud edge interface. I am fond of kind of creating acronyms, so this is DevOps multi-domain infra orchestration, comes out to domino, like you put dominoes together and it comes together. So this is not public cloud edge interface. Public cloud edge interface is, well, the same, it's describing it, but public cloud edge interface is really kind of like a very dry term, right? But this is more fun, right? So so speaking of this, just revisiting this, what we're trying to do in the public cloud edge interface is to enable this multi-domain orchestration. So Nurit was talking about this, and I didn't have time to ask a question, but this is another take on how multi-domain infrastructure orchestration and then application deployment on that infrastructure could be enabled. So we see this basically as an interworking problem between the domains like public cloud, and public cloud will kind of separate out into public cloud core and public cloud edge. And you saw the talk from Alibaba where there is this linkage between public cloud core and public cloud edge, where the edge functionalities provided by public cloud are controlled and orchestrated from the public cloud core. They're not autonomous, right? And there is linkage in between. We also distinguish independent sort of third-party edge, and this could provide edge applications, also edge capabilities. For example, an Etsy Mac edge service could be running as a microservice in this domain, supporting in edge applications and public cloud edge applications and so forth. We do see a need to interwork with the operator network edge, and this question about distribution of UPFs and linking them into this sort of multi-domain environment is critical, right? We also recognize that this orchestration cannot happen without interconnection. And for example, the developments in Etsy Mac Federation that kind of specify the control part of the east-west bound interface do not really address this data plane part of it, right? So anyone with practical kind of experience in providing these distributed applications has to worry about the network, and the network, more specifically, is not, is not sort of, you cannot build a service mesh or SD-WAN without this fundamental interconnection, right? It's a physical connectivity, it's layer 2, layer 3, and then on top you can build a service mesh, but without it, you can't. The other part of it here, and sorry, the recent kind of events and everything, we see more and more demand for non-internet based interconnection, like non-public, right? So stuff that happens in private domains, like Clint was talking about today, is getting on the Google global network is basically getting on the private network, right? And there are different ways to protect traffic there. There are more controls, and this interconnection, increasingly happens in the private domain, for private sort of design for all this interconnection. And then this data centers become really, really critical in supporting all of this, right? So just a note very quickly on this notion of how the public cloud-driven edge computing is really kind of linking together the core cloud with the edge provided by the core cloud, which in our terminology in the public cloud edge interface blueprint, we refer to the public cloud core, PCC and PCE. And for example, what's Alibaba's example and for example, AWS Outposts, right? We have an example where the hardware, the virtualization environment, and application and services are linked. Therefore, orchestration of this has to happen through the public cloud core. Orchestration goes across, this what's called, for example, a service link. Control and data is exchanged, right? And there are various degrees of this coupling, right? One next degree is where, like an Anthos model, where hardware could be orchestrated separately, but the virtualization environment and the application and services are coupled together, and there is like a hybrid orchestration touch points where you need to manage this. This one is interesting as well, where the edge is somewhat autonomous, right? So you deploy your hardware or activate the hardware, the bare metal provider type of services. You deploy virtualization like Kubernetes, right? But the application that runs on top, right, is linked back to the cloud. It cannot function. The edge application cannot function without the cloud core part, right? Because it needs authentication, it needs control, it exchanges some data, and you won't be able to run it without having the cloud provisioned. And that happens in many examples, like, for example, AWS Greengrass, Azure IoT, and many, many more, right? And here is the completely decoupled model, where it's basically sort of a third-party application just exchanging data with the core. So we kind of think about this and see how does it affect the ability to orchestrate across these domains, right? So, and this is sort of representation of a, I guess, a use case kind of driven architecture here. So the orange part on the top is really what the subject matter of the public cloud edge interface. This is an open source orchestrator based on MCO and additions to MCO from ONAP, right? And it enables infrastructure orchestration with an innovation, I'll show it later, of running infrastructure as code, which we think is a very interesting application of infrastructure as code to orchestrating, diverse multi-domain infrastructure. And then once this infrastructure is created, you basically can deploy functions and applications on top, and same domains like we see public cloud core, public cloud edge, third-party edge, for independent services. And then here's operator network edge, but this is for specific function like a distributed UPF. There is a subtle thing here, was that this bare metal service, because this coupling relationship between public cloud core and edge, this edge provided by the public cloud could still be running on independent hardware, and therefore this bare metal orchestration, component is very important, especially if you really want to deploy this highly distributed and agile type of dynamic services, where you need to have the ability to bring up bare metal, and build the edge as it's needed. Interconnection is important, and then obviously the data center facilities. So this is, I think, one of the important slides that I wanted to talk about here. So we know that this model-driven approach that, for example, Nurit was describing, yeah, this is the state of the art today, right? But what does it mean? It means, like, in terms of if you have many domains, multiple domains, and each has different models, different parameters, it can quickly become a very untractable model, right? For example, or scenario, right? For example, we have multiple clouds today that support different services, different components in those services, different features described differently across just in the public cloud domain. It's hundreds of them, right? Creating models for each one of them is really difficult, and let alone making those models uniform and common, right? This is very difficult. Then you're talking about other things, like, for example, in the interconnection domain, how providers provide networking. What's the services and descriptions there? This is more tractable. For example, MEF has a very good Metro Ethernet forum and approach to it, but still it's different, could be different from provider to provider in terms of the actual kind of APIs and how it's implemented. And, we're talking about here, at the edge, it's completely non-standardized and everybody does their different thing. But what's emerging is this infrastructure as code approach, right? In other words, any infrastructure could be described in a common language as resources and data, right? And then everything is described in programs, right? So this Terraform templates are programs, right? And effectively what happens is that the orchestrator with this Terraform microservice or infrastructure as code microservice, it becomes model free. It becomes like a CPU. So it retrieves code, right? Runs the code. It receives parameters, for the code, data for the code, runs the code, and then through a common and uniform way of passing this information to actual domains where there's sort of an agent that runs that translates this into individual APIs. And so what happens here is this uniformity, Sorry about that. Yeah, uniformity is achieved because every resource is kind of like described in a common language, right? Model free, it means the orchestrator doesn't need to know about the details, like what happens in every cloud to describe every little parameter that has to be accounted for in the orchestration model. All it needs to know is where to pull the program to run that orchestration, from, and then the model is in the program. And it happens to be in Terraform, for example, as an example. Helm charts is an application level program that describes how this can happen, right? Another very interesting part is that external state. So once you create this infrastructure, you have a state of what you just did, right? If the state is stored in the orchestrator, then the orchestrator has to become a critical component of the infrastructure, and that's not desirable because you have to have flexibility. So this method actually provides a way to store the state externally, retrieve it when needed, and then act on the state to iterate, and that enables this DevOps-driven approach, right? So with this approach, the act of creating fundamental infrastructure itself can be part of a DevOps process, not just the application, but actually creating the infra in the cloud, like physical and virtual infra in the interconnect domain, where we could create connections to between the edge and the core and the network. And then at the edge is very important. Like bare metal could become actually the act of activating bare metal could be part of the DevOps process. Sorry, keep jumping through. So the next part, I'm not going to go through this, but this is, if you go on the PCI wiki, you'll find this architecture kind of realized in the implementation of the public cloud edge interface domain, where we follow the structure where we have the public cloud providers, edge providers, interconnect providers, operators, and developers able to really kind of utilize this orchestration for infrastructure creation, application and function deployment as part of a workflow, right? So this is not just sending API calls, as by the user, but you could actually create a workflow that would kind of pace through what needs to happen in the cloud, in the edge, connecting the cloud to the edge and to the network and so forth, as an example. So I'll spend a little bit of time, but this is a little bit busy here, but it's actually a working demo that we have for the public cloud edge interface blueprint. It shows the architecture of this multi-domain orchestrator, starting with the blue components here. Light blue are sort of design and development DevOps type of components, where we have the ability to store and publish the those infrastructure as code programs, Ansible playbooks, Helm charts. Even the cluster configs could be stored and retrieved for onboarding. And then we have a prototype of this software infrastructure design studio that allows to graphically build some components here, like pick the cloud location, pick the edge location, pick the network location, connect network to the edge, edge to the core cloud, and so forth. But this orchestrator then will also have this workflow engine that it's fairly complicated, but its purpose is to compartmentalize the infrastructure as code programs so that they're not a monolithic piece of code where you could run these things and exchange parameters when needed. For example, in order to create connectivity between the edge and the core cloud, you need to have authorization keys. Like how do you, and they're generated in the cloud, but they have to be known at the edge, right? In order to create a connection, right? And that's some tricks that need to be taken care of in order to be able to exchanges information, and the workflow engine is something that could accomplish this. Then we have the MCO component, which is the LFN project, right? We have basically the ability to deploy applications on top, but before that, we can basically create this infrastructure with private connectivity in the cloud. We use Equinix Fabric and Equinix Metal as an example of composable infrastructure. These are physical components, right? Layer 2 virtual circuits over fiber connectivity between cloud location and edge location. We tried this in Silicon Valley, this in Dallas. Bring up the bare metal server, switch control to Ansible to install Kubernetes, and then switch control to Helm chart processor to actually deploy edge application here, Azure IoT Edge, with supporting routing capabilities like this BGP that's required in order to connect to the cloud. And the recent development, we actually have a successful deployment of the free 5G core, just like we talked about in the 5G LTE blueprint, in order to complete all of this. This is the new edition. We can, if anybody's interested, we can provide the demonstration. So, and briefly on this question about who is Equinix, just I wanted to introduce the company. So, the company, this is our logo. This is a fortress, right? Sometimes I interpret it as a signal wave, but this is a fortress, meaning that what this is for is equal, neutral Equinix internet exchange. This is how the company started. This is what we represent, is really the neutral provider of data center colocation and interconnectivity services, and recently just in additional services in virtualized domain and bare metal cloud orchestration. So the company, let me build this out real quick. So the company started as basically a private internet exchange, right? So as Vint described in the beginning of the call, the internet, was centralized first, and then, these relationships between internet providers we're looking for a neutral player to host the actual equipment, provide for peering, and this is how internet, got scaled, right? Then, this was represented by the presence of the web. So the web services started co-locating their resources with this interconnection. Same, trend was in the electronic trader, because then you cut out cost and latency and improve performance just because you can co-locate in proximity. Clouds changed all of that, to the, kind of elevated all of that, where now access to clouds could be provided, through these facilities, and then we're going into enterprise and edge, and we view all of this as an ecosystem of, providers and consumers, and really providing this neutral capability to consume services, deploy services, and interconnect them. Okay. So just to give you a sense of the scale here, Equinix operates in 240 data center facilities. So this dots here are actually campuses of buildings, like 10, 12 buildings in Silicon Valley, in Ashburn. We are in 68 metros around the world in 25 countries, 10,000 plus customers, and this is the number of interconnections. And these are very critical infrastructure facilities. They operate at 6 nines, and this is not a made-up number, right? This is the number. This is the availability of this type of critical infrastructure, because locations like Silicon Valley, Dallas, Washington D.C., New York are basically where the backbone of the internet runs. Amsterdam, Paris, London, right, and in the APAC. So what you see on the screen is both the data centers and the private network that interconnects them, that we can provide connectivity in minutes, right, because of the APIs and infrastructure as code capabilities that we have. And speaking of that, so basically, we provide the data centers of different type, right? So this would represent the macro edge. These are, large facilities, multi-tenant. We'll also build infrastructure for hyperscalers, and we're looking at, certain things that we could do at the edge, as I described. We have the network from physical networking to virtual networking, as shown in the Equinix Fabric. Here, I'd like to kind of stop over a little bit, but we provide a very interesting set of services on top of this, right? So we have our virtualized network edge, where customers could bring up virtual network appliances that are integrated with this network, right? So in minutes, you could bring up a virtual router, create connectivity to multiple clouds and to your network provider. And then this service has become very, very popular during COVID and is growing because of that demand. On top of this, we have the ability to actually stand up bare metal. So this is really very important. This is not a VM here, right? This is a real server that customers could bring up in minutes, right? And this is, including the installation of the operating system. There's a lot of innovation that we do in order to enable that. And we support services like precision timing as well to distribute clocking across the network. Bare metal service is also integrated with the fabric. So you could realize that picture that I showed for the PCAI at the bottom that has multiple kind of resources in minutes. And PCI as an orchestrator, enables that through the use of these things here, infrastructure orchestration, specifically Terraform that we provide, APIs, and people could use portals as well. So this is really, another way to look at our distribution. So if you take the map of the United States, and this dark smudges are population density. And these dark circles here are roughly 10 millisecond round trip times, very simple model, fiber-based, like no extra hops. And if you count the number of people and their GDP in those circles, right, it will come out to approximately 80% of urban metropolitan population in the United States. Same holds for Western Europe. And this is really where we think, because of the interconnectivity infrastructure capabilities, this is a very good way to start kind of making 5G real, where you already have this ecosystem of consumers that's connected to these locations. Adding 5G would be very beneficial all around to consumers, to providers, and to the technology itself. Another piece of information that I wanted to bring up is that we're not just kind of talking the talk, we're walking the walk, because we've built in our 5G and Edge Technology Development Center in Dallas. Rodney here. Rodney is from Equinix. Please wave. Yeah, we work together on building this 5G and Edge Technology Development Center. The purpose is to showcase how this infrastructure could be leveraged for 5G. And what we're building is this type of architecture where we showcase this micro edge, macro edge, showcase how existing services at the macro level could be integrated, including this fabric, network edge, and the bare metal, and how the rest of the sort of layers could be built, including this orchestration, which is not a small part in order to enable the automation and distribution of the edge. Right, and we're active in the Linux Foundation, in the open source community. So Linux Foundation, of course, we're top level membership. We have a governing board member seat, technical steering committee on Akraino, and the public cloud edge interface. LF Networking, we're present, and CNCF, we just recently were elected. Our CTO, Justin Dustade, was elected as the board member. So we're active in all of this, open source communities. And yeah, so would like to really kind of call to action is to collaborate, reach out to us if you're interested in doing work in our 5G and Edge Technology Development Center. And, obviously in the public cloud edge interface blueprint, for orchestrating all this and demonstrating the capabilities. Thank you.
Perfect. Any questions, comments?
Hi, thank you so much, Oleg. But Tina, do we have time? Bat has been waiting. Do we have maybe 1 minute or?
One question.
Oh, absolutely. No, I just would like to make this remark. I don't know if it's valuable for you about these 5 milliseconds that you mentioned about the latency in the specifications in the 3GPP from 1 to 10. Actually, the subscription for latency is defined as platinum. From 11 to 50, it is defined as gold, and from 51 to 100 is defined as silver. As majority of the implementation are on EPC, the latency you have to establish from S1 to S5, from S5 to S8. So it's very difficult, while in the 5G SBA, you have end-to-end tunneling. where the quality of service actually can be in latency, plus there is a multiplexing that you can implement. So majority of the operators that have implemented the core on the EPC, they request 5 milliseconds because then the suppliers can provide 50 because of, the challenge with the EPC and quality of service, to meet the latency. At least this is, the assessments that I have come across that I wanted to share with you.
This is more infrastructure oriented, and if somebody says we can do 5 milliseconds, they have to worry about all this stuff. So that's the point of the slide. But thanks for the comments. Sure.
Anytime. Thank you, Oleg.
Thank you.
Appreciate it. If no more live questions, we can take it offline. And you talk about your work with operators. Now we have Verizon. Beth is the next speaker. Beth?
Yep, thank you. Let me share my screen. Although I'm going to be talking about Aniket, which actually ties directly into the previous conversation with Oleg. So let me, I think this is the right screen. Yes. Okay. Okay. So everybody see my screen?
Yep.
Good. Just setting everything up here. Okay. So what I'm going to be focused on is the Aniket project. So I'm one of the TSC co-chairs along with Gergely for Aniket this year, and I want to talk about what it is and why I think it's important for Akraino, and I think Oleg's presentation highlighted that, even though I didn't say any mention of Aniket at all in it, but a lot of what we're working on is ties in directly. So let me continue going here. Let me get there we go. So I'm going to talk a little bit about what Aniket is. I don't see a whole lot of people on the call who have been participating in it. So hopefully this will be good information for you. A little bit of history of where Aniket came from. Also talk about our test Aniket Assured program, which also is probably of interest to the Akraino project. And again, why is it important to Akraino and where we're going? Feel free to, I know it's a small enough group that if people have questions along the way, it's fine to break in. I can handle it. And I know we're running really, really late. So I don't know, Tina, what's the protocol for the fact that we're running?
As long as the Kura is okay, so you are the last two speakers standing before lunch.
Okay.
I think Kura said it's okay, right? Yeah, he said that too.
Yep,
yeah.
That's fine.
Okay.
Thank you.
So Aniket, where did Aniket come from? What's the problem that we're trying to address? And the answer is that in the telecom workload world, we have been moving away from appliance-based services and moving more toward software-defined networking of various sorts, or we actually have started calling it more workloads, because it's not just network services, traditional network services like routing and SD-WAN and firewalls. It's network slicing, 5G, a lot of things, and a lot of supporting services require have been moving away from being physically based more toward software. So, and we have so the telecom world has been building these cloud systems for a while. We are public cloud, private cloud, kind of moving back and forth. A lot of inconsistency across the telecom industry. And that makes a problem for the NFV vendors, the ones that are providing those services, because they have to build support for, you know, every telco cloud out there, which is always a little tweak of something. So that can be very expensive, doesn't really add value to anybody. As one of the founders of the Etiquette project, which was previously called CNTT, said, telcos are competing on services. We don't compete on what infrastructure we're running our applications on. So it makes a lot of sense for us to get together and create some reference architectures. So that's, you know, that was the nutshell of the start of the project, which started about 3 years ago now. So the objective, there's some business objectives and some technical objectives. The business objectives is to reduce the time to market, reduce TCO, you know, total cost of ownership, consistent operating model, more efficient use of our infrastructure. Infrastructure is expensive to build. Certainly Oleg is well aware of that, running Equinix data centers. But we're also looking for the ability to automate these systems. You know, another big factor is the verification and testing. One of my coworkers said, if we can cut out 10% of our testing because it's been tested, you know, by somebody else, that is literally millions of dollars we've saved. And it also means that we can get our services out faster. So just in general, that was where we were, what we were running against, and some of the things that we were looking for to with Etiquette to address. This, you know, kind of going up a little bit and getting into the weeds before I kind of go down again. We were very careful to focus on the infrastructure. So if you look at the red in here, this is the scope of the Etiquette project. Obviously, Etiquette touches other projects. It touches particularly ONAP. I think it touches Akraino as well. But it's very much focused on the infrastructure end of things, with the ideas that there'll be, there are definitely interfaces that will touch other components, specifically the management aspect. So over on the right side here, we have the orchestrators, the VNF managers, you know, and this is typically ONAP kind of falls into over here. So we're touching ONAP, but we're not, you know, getting into ONAP's place. So the idea is this is a gap. When I didn't put a slide in here, but there was a slide that showed there was in fact that I had created that showed that there was in fact a gap in the, you know, the projects that, you know, and we were working on the, you know, orchestrator with ONAP. There's a lot of work on the VNFs. There was almost no work on a common understanding of the infrastructure. And so that's where Etiquette fits. And, you know, you can see, you know, there's interfaces, obviously. And then there's, you know, the underlying hardware resources. That's actually something that the Etiquette is working on. Well, how do we explain our reference architectures against hardware? Because there's, you know, hardware disaggregation, which is never 100%. And, you know, how do you reconcile all of that? So these are some pretty knotty problems that, you know, the project's been working on for the last couple of years. So any questions before I go on?
I mean, Beth, very quickly, do you have any overlapping with Etsy NFV? and Mano, OSM Mano?
We interface with both of those, but we don't overlap, if that's what you mean.
Okay. Okay.
Yeah.
Thank
We
you.
use the ETSI definition to establish this picture. Actually, I think did in fact come from ETSI.
Okay. Yeah, because I mean, thank you. Okay.
Yeah.
But one thing, how is going with the GSMA OPG? Are you the one who is feeding them with information?
Yes. Yes, we are. Yes.
Okay. And do you have an impact on this end-to-end?
Yeah, they accepted. So the reference model, and I'll talk. I have a couple slides in a bit that kind of talk about the different components. The reference model, which is what we're feeding to GSMA, the first version of it was already accepted a couple months ago.
Okay.
So absolutely, we are working very tightly with the GSMA. The chair of that particular GSMA group is Walter from Telstra, and he's also
okay, yeah. I mean, they have implemented,
yes,
network as a service from TM Forum with the.
It's all interrelated.
Yes. Okay. Thank you so much, Beth.
Yeah, the intent, absolutely, right from the beginning, the intention was not to reinvent the wheel.
Absolutely, yeah. Thank you.
So here's our mission statement. And I want to focus on the reference cloud infrastructure models, architectures, conformance programs, and tools to deliver networks services faster, more reliably, and securely. So this, in a nutshell, is we're really focused on the infrastructure piece. And unlike most, many of the LF projects, this one is actually more architecture and requirements driven than code driven. We do have some code. It's mostly testing tools, but primarily the major output is in fact the models. So project scope, again, this just taken directly from our webpage. So we're really focused on creating those reference models that are, the telecoms and the vendors that support the telecoms can use to either develop, in the case of the telecom, develop build out the application infrastructure to support the applications to deliver our services. Speaking as Verizon, our business models, of course, we deliver services, telecommunication services to our customers. And we need infrastructure and we need tools to do that. We work with our vendors to build out those tools. The other component, of course, is that the vendors need to work from a common reference model and reference architectures to build those tools. So it's really, think of it as a partnership between the groups within our ecosystem. And that was, again, something that was very important to the founders of this project. We support open source, open standards. As I said, we use ETSI, GSMA, we're in MEF, and TM Forum and other standards bodies and open source communities, OpenStax, and the Open Infra Foundation. So we're tapping into these other communities. Testing and validation, very important. Again, I'll talk a little bit more. I have a whole section about that. And a conformance framework. And and we have ongoing activities to continually look at new ways that infrastructure is developing, and particularly focused right now on the containers and Kubernetes, but we also understand that Kubernetes is the hot thing now, but in 5 years something else will come along. So moving on. So all that verbiage, this is the translation. We're establishing reference model, reference architectures, and we have a single reference model and several reference architectures. Currently, there's 2. The intention is that there'll always be just a relatively small number to support cloud native workloads and whatever those mean. And active participation with both the vendors and the operator communities. That's extremely important. The technical steering committee is in fact made up of a mix of vendors and operators. By our charter, we need a mix. We follow a two release a year, 6-month cadence. We're currently on Mosel, and Nile is going to be the next one. The cadences, it's January and June are the two releases. And then the validation program is called the Aniket Assured Badging Program. Again, I'm going to talk a little bit more about it coming up. We're always looking for additional test cases to fold into the program to make sure that we're in alignment with the other projects. So here's the community organization. So we have the Aniket TSC in the middle here. And here are all the work streams. And Ike, here's GSMA over here. Other projects that are involved. TIP, CNCF, we're very active with CNCF because one of our work streams is focused specifically on CNCF. Another work stream is tightly coupled with the OpenStack. So that's the open infra projects. So as you can see, this project is probably one of the more integrated project with other open source projects. We're all working toward a common goal, developing together. So it's very much, there's a lot of architects in the project, probably again, more so than in other projects, because we're building architecture requirements. So let's get into the nitty-gritty of the work streams, what the work streams are. Again, we have the partners over here. So we have Etsy, we have GSMA, 3GPP, the CNCF, Open Infra, and ONAP. And we haven't done a whole lot with Akraino, but I suspect there's some opportunities here. And then we have the reference model, which there's a single reference model, which is tied in. The reference model feeds into the GSMA project. And then generally there's the cadences that we take the reference model documentation, give it to the GSMA. The GSMA runs it through its own processes for approving it, and then it gets approved and published. So we've done, I think, 2 iterations of the reference model GSMA so far, process flow. And then the reference model feeds into these reference architectures. And we currently have 2. They're called RA1 and RA2. We're not overly creative about our naming conventions. And RA1 is the one that's based on OpenStack, and RA2 is based on containers or Kubernetes. We started with RA1 because, as you probably are aware, most telecoms do run OpenStack infrastructure as their underlying supporting clouds. So we actually had going in quite a bit of experience with OpenStack as infrastructure. So, the telcos could get together and, really get pretty far on that reference architecture fairly quickly. So that's why we started with that one. RA2, which is Kubernetes, is something that's newer. for the telcos. The telcos, have a direction, in general, do have a direction that we want to move toward containerized workloads. However, a lot of workloads are not containerized as of yet for a variety of reasons. So it was more, RA2 is much more an opportunity to create the standards and the references. RA1 was really more focused on capturing existing reference architectures and best practices from the various telcos that were participating, while RA2 was really going into new territory. And then from there, so the dark green here really represents requirements. So business requirements, operational requirements, technology requirements. And then as we move to the right on this diagram, we're moving away from requirements and moving into coding and testing. And again, these are reference. So what we have is what we call reference implementation. So that pulls from the reference architecture and creates an implementation. And those are, stood up in community labs. The one at the University of New Hampshire has one. There's others. Intel's got one. And the code part is it builds installers to support these reference implementations. And so these reference implementations can be used as is, although I think most of the telcos, can take it and then modify it to meet their own requirements. But the idea is that we're at least starting from the same vanilla platform. Also, obviously, allows it to, fit into CI/CD and other types of development. And then finally, we have what we call reference conformance, and that is testing. And there's a whole series of tests that we've developed. Some of them came from ONAP, sorry, not ONAP, OP-NFV, which was one of the Anakit came as a merger between OP-NFV and the CNTT work. CNTT was mostly focused on the reference side of things. OP-NFV was more focused on the testing side. So they really, it's a great merger and marriage. And then what's coming out of that is the compliance and conformance and verification process, with the idea that companies can go in and get badged to say that their models, which are tested, or they can test it themselves, do in fact meet go through and meet all the test requirements. So I've said a whole lot. So I want to stop and see if anybody has any questions before moving on.
Just a comment. I think the light green part could be, reminds me of Akraino. This is basically like a blueprint level approach. Obviously, you have a lot more, I guess, standardization here, but I could see how Akraino could take the reference architecture, for example, for Kubernetes, and try it in one of our blueprints. And,
yeah, I definitely think that would be worthwhile. Because by the way, we did have a whole thing around Edge. We kind of we started having a separate work stream, and we realized we actually didn't need a separate work stream. We just kind of rolled it back into the reference architectures, both RA1 and RA2. So
thank you.
So here's the adoption process. So reference model is an NFVI abstraction of the services and resources exposed to the NFVs themselves. So this is the NFV infrastructure. So the model is pretty high level, obviously, but then it rolls into the architectures, because the model sets up a lot of principles and best practices, and then these roll into these architectures. And this actually was taken from one of an older, when I think I wrote this slide up a couple years ago when we were first getting started, but it's still holds actually. So it says the expectation there'll be only a few, maybe 3 to 5 reference architectures, and currently there's 2. There was talk about doing a third one. I think VMware was talking about sponsoring one to do their architecture, but that never came to fruition. And then, of course, as I was talking about, the reference implementations flow from the reference architecture. So it's RA1, RI1, RA2, RI2. So they all kind of flow down.
Right. Beth, thank you. I'm just a little bit curious when you say that, of course, very rightly, the focus should be on the services and workloads. But do you have some impact on the 3GPP SA1 with the requirements? Because now suddenly you see such a huge focus on these services and based on certain capabilities like service function chaining, like multi-access based on ATSS. Suddenly slicing, they're utilizing, if you look, dynamic spectrum sharing and frequency division duplex for 3 different configurations like subscriptions or some kind of priorities or some kind of coverage area, and 13 different solutions. On NPN, SMPN, they have 6 different configurations, but 56 different solutions. On the industrial IoT, they have 5 different configurations and 25 solutions.
Right.
And do you somehow have an impact with this, partly with your reference model? Because, I mean, they have this interface reference points and also the resource models that they have also on the management. And do you feed them the SA1 on the requirements because of your testing?
Well, that's exactly the intention. That's exactly the intention, because the vendors that, in fact, actually on Monday and Tuesday, we're having a DTL, and Monday, the subject of Monday's DTL is to gather requirements from the vendors for containered, the container, so RA2. Because, again, except for maybe, Red Hat and some of the infrastructure vendors, the vendors of the applications that sit on top of infrastructure, it just costs them money to support, 50 different solutions, right? Exactly. There's no value add to anybody in the industry.
Very interesting, because right now what's going on with the 5G advanced, and it's going a little bit very quickly, and it's extreme huge focus on these services, on this intent-based management, automation, and a little bit, I mean, using context. Suddenly you're seeing, using the application context transfer and reallocation for the discovery of the edge application server, using the edge application server discovery functions, and particularly these policies. And when you look now with the subscriber also aware, northbound APIs going directly from the third parties APIs, internet service providers and content providers directly to the subscribers. So you have a seamless use of these services.
Right. Yeah, I'm working on the MEF team that's working on those APIs. So yeah, it quickly gets very complicated.
Yeah, you have, copy fate, suddenly, enabling this API exposure function for the service exposure and network exposure. Extremely interesting, because the people who catch this and connect these dots, they will have in my opinion, a huge advantage in partitioning and offering targeting, particular user groups based on connecting these capabilities. Yeah. Interesting. Thank you so much. Very exciting. Very exciting. Thank you.
anyhow, this just highlights the work stream process, which I think I've pretty much kind of covered, but this pretty picture. Again, we have the GSMA reference model tie-in. We have the CNCF tying into, all these implementations. We have the labs, we have the installers. So we're currently supporting Airship and BMRA. We have the testing framework, of which we're actually developing more. That's actually one of the areas that we're really expanding. We have Funk Test, which has been around for a couple of years, but we really need to build out test frameworks specifically around CN, the Kubernetes and container-based applications. And then we have the governance and the badges. So continuing on. So here's just, some of the project. So again, this just highlights the project outputs. So the reference architectures specifically are typically documentation. And then the implementations are actually, implementations that can be stood up in a lab. And then, of course, we have the conformance testing. So we have a set of tests here, and then the badging. So here's some of the project objectives that we're working on right now in 2022. So we're looking at hybrid multi-cloud models and seeing how they, what reference models and how that changes the, changes the requirements. Again, Oleg, that's probably of great interest to you.
Yeah, I was just going to make a comment on Airship. There's been some conversations about integrating Airship into this public cloud edge interface orchestrator. So it's very interesting. Yeah.
Yeah. And again, I don't have to tell you, multi-cloud is the way to go. That's what, that's what the enterprises are doing. And that's, and the telcos are moving in that direction as well. I know we use OpenStack. We also use AWS. We also use Microsoft Azure. I think that's where companies are going. Certainly the telcos are going that way slower than the enterprise. I'd say the majority of our enterprise customers are asking for interfaces to, you name it, it's usually AWS, Azure, and Google. Those are kind of the three big asks. We have a whole project that we kicked off called Thoth, which is focused on intelligent networking and AI and machine learning. That's, as we got into it, we're really finding that the data, there literally are no data sets that can be used to test AI and ML algorithms and models. So, currently the operators are all kind of bumping into walls and in the dark about it. I mean, I'm working on that project, and literally, inside Verizon, we have data lakes that, we have 5 different data lakes, and they don't talk to each other, and they all define things differently. And that's just within Verizon. So I can imagine that every single telecom has the same problem. So it makes it really difficult to do any kind of research on intelligent networking when you literally have no standard way of testing anything. So I actually participated in a white paper that was published by the EUAG last year on the challenges of intelligent networking. So it's worth a read. It was based on a survey. And we discovered, whatever anybody's saying, the reality is that we're just started on that intelligent networking journey. And we're hoping that the Thoth work will forward it faster. So this is the release, what we're looking for, hybrid and multi-clouds, Thoth, data models, as I just mentioned. And then we're going to be adding additional, specifically around security and lifecycle requirements. That's another area that a lot of open source projects don't tend to pay much attention to, but the telecoms, of course, are very interested in, is support for lifecycle, right? Because, at the end of the day, we're stuck operating this stuff. And, typically we're operating this infrastructure for years. I know, OpenStack is still doing every 6-month updates, and I don't know, it's up to it's past train, and we're still running Newton, so we're way behind, and again, that's pretty typical of what you see in telecoms. They're just a couple years behind because it's not easy to do updates, because there's a lot. You can't just tell your customers, hundreds of customers or thousands of customers are sitting on this infrastructure. Hi, we're going to take it down over the weekend. See you on Monday. It just doesn't fly. We're very concerned with, life cycle. How do you do migrations? How do you do upgrades? And security, of course, I don't have to tell you, is really important. So this is like a little bit of a history lesson, and I think it's important to understand, because then you can have better understanding where Anakit is. So OPNFE was founded in 2014. It was created to build an open source reference platform. It wasn't well defined about infrastructure. It was really, that was, I think, part of the problem, and possibly it's because OPNFE was, a little bit before its time. It had trouble getting the telecoms to participate, so it was kind of taken over by the vendors. It joined the LFN in 2018 when LFN was created. But again, it was mostly a vendor-driven project, so I don't think it got the same kind of attention that the operators were, I think, a little frustrated. I know there was a fair number of operators that looked at it. I know Verizon looked at it, decided not to participate because there weren't enough operators. So sort of independently in 2019, we created this CNTT, which it came out of the operator community. It was originally founded by AT&T, Orange, Vodafone, and Telstra. And then Verizon was actually pretty early. There was a couple projects. There was a project in GSMA. There was a couple projects floating around, and they all kind of coalesced into CNTT. And then CNTT, opened up very shortly. We had a meeting in Barcelona. There was about 15 people there. And then we, in July, a couple months later, we did pick the hottest July week of in Europe, in Paris. It was 108 degrees, unbelievable. And we got together and we invited, it was telecoms and the vendors got together. It was about 75 people showed up. And that was really, CNTT got going then. So we made a decision to, be partner with GSMA right from the beginning. And again, it was always seen as a partnership. But CNTT was full of a lot of architects, not so many developers and testers. So it became really obvious that we needed to merge, and we did in fact merge together in 2021, in January 2021. Here's the original vision. Actually, I dug this up. This was done by Rabi Abdul, who's now at AWS. So as you can see, it was definitely focused on that infrastructure stack. Here's the infrastructure stack moving into, at the time, we were going to feed into OPNFE, but then we realized we should just merge together. And then we have all the applications sitting on top of everything. So this kind of talks about where, the two groups were coming from and why it makes sense for Anakit to it's a happy marriage. Let's put it that way. And I'll skip this. That's boring. So let me talk about the Anakit Assured program. So just before I get into this, and I only have a couple more slides, by the way. Any questions so far?
No, thank you. It was a very good overview of the history.
So the Etiquette Assured program, which is a rebranding of the OPNFE verification program, is focused on having a verification program for infrastructure, workload, and labs. So, or lab hasn't come out yet, but the infrastructure and the workload did just get released. And the idea is it has ONAP components, has Etiquette components. I think it could have Akraino components for that matter. And the idea is that the companies can get their services, their applications, whether it be infrastructure or whether it be VNFs themselves, they can get them badged to say that they pass the criteria or the test harness, and that they meet all the criteria that are identified in the test. This is how the Etiquette Assured program works. So the projects currently, you hear the projects that are feeding into it. We have the LFN governing board, which just has oversight. The CVC is in the middle here. So this is the Compliance and Verification Committee. There's a lot of, the CVC and the projects, obviously there's a lot of collaboration to make sure that the testing requirements are what the projects need and want. And then the projects provide the technical requirements and the test implementations, i.e. they write the test, and the CVC provides the project oversight, the program, works with the vendors, and here's the program. And here's just some benefits of the program for everybody. I think, as I said earlier, if we save 10% in testing, that's millions of dollars. And here's just information about how to participate in it. And okay, so what's in it for the community? So we have, the network operators get, reduced complexity. We limit the number of infrastructure platforms. It's not, one of everything for, every single network operator has a different platform. Reduces our capital expenses. It just makes, simpler operations, simpler RFP process. And for the vendors, they have, reduced development costs. You don't have to make development for every single, telco out there. Faster testing intervals, it's just benefits everybody. And that also applies to the infrastructure vendors as well. Here's our community. There's a lot of companies out there, and it just benefits, as I said, benefits everybody. I think I've talked about this already, so this kind of covers who else we work with, and just we have a program called the Etiquette Ambassador Program, which is people who can talk to companies and projects. So I'm an Etiquette ambassador. So we're working with organizations to make sure that we get the message out. And this is just information about how to contribute to Etiquette. So with that, hopefully you'll be able to go to lunch.
Thank you, Des. I think we have already gone through the questions during the presentation.
Yeah.
Yeah.
So I think we did.
Yeah. I think there's a lot of interaction area. Akraino can work together with Etiquette. Let's roll it up in 2022. We'll keep in touch and
Thank you so much, Pat. Very much appreciated. Thank you.
Good. Yeah, I really think that I was involved in Akraino in the beginning, and then, I kind of got sucked into Aniket. But I think that there's a lot of opportunity here. I think there's definitely some overlap, or not overlap, but synergy, I think is a better term.
Right. And Kura, next speaker, and our last speaker, he's gonna talk about Noodle, a part of ICM Blueprint. And I think it definitely leverage and use the Aniket technologies. Kura, are you ready?
Yeah, I'm ready. Let me share my screen. Can you guys able to see my screen?
Yeah, yes, I can.
Okay, cool. So I will be talking about Node.js. It's one of the project within Akraino community, and it's also have a connection with OpenNFV community, because Node.js was part of OpenNFV community as open for NFA project, and later it was decided to move into Akraino community as well. So let's jump into what is Node.js. So the Node.js is basically like networking controller for Kubernetes networking. So I will be talking about where is Kubernetes networking, and what are the things is there, and what are the things is lagging, and why we required Node.js, and what kind of edge networking use cases it's bringing. And I will do a very deep dive into Node.js, and also we'll be talking at service function chaining model as one of the edge networking use case. So let's have recap about networking, right? In Kubernetes networking, as most of the speakers spoken today, like one of the de facto orchestration engines for the cloud native network is Kubernetes right now. And the one of the things we see in Kubernetes is that the Kubernetes networking, it's more for enterprise segments, for in terms of telco or edge use cases. The Kubernetes networking doesn't support a lot of networking concepts that we are looking forward. So as you know, in Kubernetes, all the networking heavy liftings are taken care by the CNI or container networking interface, and and networking in Kubernetes always remains out of the scope. And because since the networking is already taken care by CNI, the Kubernetes always assume that it's basically requires only one single interfaces, and as long as the CNI binary able to provide the IP address, it's all good to go. But in terms of the telco, cloud, or edge networking, right, we want to deploy the CNF and VNF, excuse me. The Kubernetes networking doesn't handle multiple networking interfaces. That's one of the major requirements for the CNF as well as for the VNF. So in terms of VNF, right, in Kubernetes, there is some various projects, for example, KubeVirt or Virtlet project that will help us to enable or deploy the VNF application using Kubernetes as orchestration engine. So in those cases, right, how the networking will help at the first place, right? How you able to address use cases such as software defined networking, and how you place a virtual VNF or CNF in virtual or a provider network, and how to deploy service function chaining, and all these things are basically lagging in Kubernetes, and there should be some kind of a solution that we're looking forward. So that's where the name we came up with a project called Nodus, and Nodus is a Latin word for node. As the name suggests, we want Nodus as to be a networking controller in Kubernetes that basically converges various Kubernetes concepts. And one of the first use case we are trying to target is service function chaining. And excuse me. And it takes care of edge networking solutions, and it supports containers and VM, as I was talking before, right? So in one of the use cases in edge is that the edge able to handle both the CNF and the VNF networking, but as you know, the edge computing power is very less. So in this case, how the networking solution can able to handle both the container and the VM based solutions. That's one of the major use cases we are seeing, and also while interacting with the customers, we see it's one of the major requirements. They want some kind of a single software defined networking solution that could able to handle both containers as well as VM. So in this case, I just want to show the difference between the enterprise segment or data centric applications towards the edge computing applications. So in the figure, you can see the microservices, excuse me. We have multiple microservices in the public and private cloud, where all the microservices basically remains in a single data center, and deploying them is very easy, right? Because it's enterprise segments, and most of the applications will be basically required a simple networking solution. But if you want to deploy the same microservices in the edge based solutions, for example, if it's a public cloud or private cloud, and as I shown in the figure, right, there is a multi cloud infrastructure of the networking solutions look like. For example, the microservices will be basically distributed in multiple edge locations, and they require to be interacted with in a secure manner across each edge location. So how are you able to deploy such diverse and secure networking solution? That's one of the challenging for the edge computing as well as for the telco worlds. And that's all the things we are planning to target in Node.js, and we already take care of few of the use cases as well. So let's zoom into the one of the edge locations, right? So when you look at the one of the edge locations, normally what happens is that you have one Kubernetes cluster, and you have multiple tenant across the microservices. You have resident tenant 1 microservices and tenant 2 microservices that should able to share the single edge locations, and you are required to have various networking solutions. For example, you have firewall applications that connected to the corporate network that's attached to a physical provider network, and on top of those physical provider network, you will have multiple networking functions. So in this case, I have shown the example such as smart load balancer, next generation firewall, and SD-WAN CNF application. And in the right hand, right, obviously it has to be connected to another physical provider network that's connected to the external router, through which it connected to the WAN or the intranet. in that case, there will be multiple flows, right? For example, if a client want to consume the microservices through the internet, it has to go through all the way through all this networking functions and through the ingress gateway, then to those microservices. And this is one of just one flow, right? It's the same way if you have a physical firewall box and it's connected to a corporate network and it wants to consume some of the microservices, then it has to go through the provider network, then to the smart load balancer where it basically load balanced, and then it goes to the Kubernetes, Istio, or any kind of ingress load balancer, then it hits the microservices. Yeah, and the same way, if the any servers that connected to a corporate network want to reach the internet, again it has to go through those networking functions. So if you accumulate all these use cases, right, or how you able to deploy all these workloads, right? So that's where Nodus comes in, right? Basically, Nodus will give you some kind of a sandbox where you could able to deploy all those microservices on top of virtual networking. For example, in our case, we take O1 as a default SDN based solution for Node.js, and using O1 as a networking solution, we could able to provide virtual networking, provider networking, and also service function chaining. And if you look at what are the various features we offer in Node.js, for example, the first one, as I mentioned, is network function chaining. So I was mentioning about various flows in the previous slides, right? So this is one of the just 3 flows, right? If in the normal edge scenarios, there will be multiple flows, and those flows require some kind of high performance networking and even some kind of a smart NIC or IPU based offloading, right? So the OVS is one of the solutions we have identified it, that is basically structured and table based pipeline that enable us to deploy multiple use cases. For example, it supports both L2 and L3 as well. So these are the reasons, as I mentioned in the previous slide, right? The reason we have chosen O1 for Node.js is the possible to deploy multiple use cases. For example, if you want to deploy, implement Kubernetes networking policies, and the O1 as the ACLs, which able to do those things. And the same thing for load balancing. Already the O1 supports O1 load balancing, and as I already mentioned, that all the smart NICs or IPUs of loading is so friendly in O1 or in OVS. So that's all the main reason we see in the future, or right now, most of the deployments will be moving towards OVS because it's very programmable controller, and the Nodus will be one of the entity that's basically corresponds between the Kubernetes user as well as the O1. So this is the one of the architecture is very cool. That's how we able to decompose O1 and as well as the Kubernetes concepts together. So in the figure on the left hand, you can see the O1 control plane where we have microservices, all the O1 entities for northbound and southbound databases, and in O1 controller where we have packaged the OVS switches and also the O1 controller together. So all this blocks is basically interact like a microservices to each other. And on the right side, you can see all the Kubernetes functionalities are wrapped. For example, networking function operators basically wrap all the virtual provider and direct provider networking and the service function chaining operators. So you can visualize the network function operator as a single operator that manage multiple operator for Kubernetes, and it basically have a pod watcher or multiple event watcher in Kubernetes that able to see what are the events is occurs on Kubernetes. Based upon that, it synchronizes those events and sends to those corresponding workloads that's running in each worker nodes or minion nodes. And so the networking plumbing work is basically taken care by NFS agent. So the same corresponding operators will have their own corresponding configurator that basically help us to do all the plumbing work for virtual networking, provider networking, and service function training. So this is basically the diagram that basically explain about the external and inter traffic as well. And this is one of the cool feature we want to talk about today is network chaining CR. So in Kubernetes, right from the services and nodes, everything is done through Kubernetes labels, right? So we were kind of fascinated with the idea that why can't we use the Kubernetes label for networking as well? So that's where the idea we got it is that we could able to apply Kubernetes labels for the network chaining as well. So you can see this chaining, for example, first you have the virtual network, and then you have some kind of application label that specify what kind of workload you have attached to that network, and then the another network that's a dynamic network one, then the application. In this case, I was showing the exact use cases. That's why I was talking in the previous slides, that you have the smart load balancer that is attached to the next generation firewall, then that's attached to the SD-WAN solution, right? So in this example, what this particular network chaining CR does is that it's basically identify all these workloads, and it basically on the fly it creates all those networking and create those interfaces for you. So the user doesn't even know or need to care about the networking at the first place. They just need to deploy the workloads, and Nodus will take care of the rest. And the sequence of the deployment of workloads is also not a problem, because if the smart load balancer is not up and next generation firewall is up, right? So the Nodus will identify what kind of workloads are up and running, and it's very smart enough to identify what is the running state of the machines, and based upon that, it can create those interfaces, and at the end it also create all those networking glues for you together. So this is one of the example, right? So far I was talking about how Nodus could be able to use as a primary networking, right? So in some cases that what we see in telco or in edge use cases, that the user wants to use Calico or Cilium as a kind of a primary networking, because they offer very flexible solutions for them, and they want to use Nodus as kind of a secondary solutions, where they want to use specifically the Nodus for the telco and edge use cases. For example, in this case, you can see the primary networking could be Calico, Fanel, or Canal, and the pods, the normal pods or the enterprise use case pods can be attached to the primary networking, and you can see the networking functions like load balancer, next generation firewall, and SD-WAN that could be attached to the Nodus networking. And here you can see the multiple service function chaining across the chain, right? If the pod wants to talk to another pod, right, it can, the traffic has to go through the service function chaining. And in the same way, in Kubernetes, there is no restriction for a pod or a services to talk to each other, right? So that path is also enabled. And the next path we want to showcase is that the same service function chaining can also be used by a physical network, and that physical network could be attached to multiple servers, right? So the packets from the packet generator that can also travel through the same service function chaining. So what is the advantage of this solution is the solution is not only applicable for the services in a Kubernetes cluster, but it's also applicable for any physical entities that are basically connected to the physical network, and that physical network is attached to the service function chaining. It can basically consume it. So this is our current status. We have developed nodes in Akraino community, and we have demonstrated multiple use cases with nodes as a primary networking, and also nodes with Calico as a secondary network. And we also able to showcase Kubernetes networking policies. That's one of the use cases I was talking about, why we are choosing Oven through ACLs as well. The things we are currently working on is how to extend the service function chaining for the VMs as well, using nodes, and how to do the smart NEC or the IPUs based offloading using Oven. And one of the major use cases we are looking forward is to how to improve the performance in nodes by using Oven load balancer. And the IPv6 is one of the major use cases we see in both telco and edge segments, because right now all those field trials or even the production grade deployments are moving towards IPv6. So that's one of the future also we are currently working on. So that's all about Nodes for today. Yeah, if there is any questions, I am happy to answer them.
Thank you, Carl. Any questions?
Thank you, guys.
I have 2 questions, Tina.
Yeah, go ahead.
Well, thank you so much. You just raised a little bit my curiosity. Let me share with you. You mentioned about this service function chaining. Now, there is ongoing enhancement in 3GPP for the next 5G advanced. That is an involvement of FMSS, flexible mobile service steering. Now, do you implement service function chaining that is specified by IETF RFC 7665?
No, I don't think so. We are so yeah.
Okay.
yeah.
Okay, wonderful. Thank you. I mean, I was just, because you mentioned a lot about telcos and this, so I thought I took it more or less as granted. So thank you. The second one was IPv6. Are you some kind of implementing SR, segment routing v6 IETF? Again, I mean, there is a lot also going on in telco with trying to replace GTPU, actually, on top of which, you know, the IP traffic is running, but it's within the monopoly of Ericsson, Nokia, and Huawei.
Okay, so the things we are working is basically mostly close to Kubernetes, right? So the Kubernetes already support IPv6 from, I think, version 1.21, right? So that's where we are catching up to provide the same support using OVS or Oven. Yeah.
Because you know, Cisco, Juniper, you know, all these, I mean, they have been trying. There has been a study in 2019, but it looks like maybe it will not go without a fight. It will not be easy. But thank you so much.
Thank you, guys.
Yeah. Hey, did you upload the presentation to the wiki page yet?
I will do it now. Yeah.
Yeah, cool. And I just want to check the status and plan of the Nodes blueprint. And so I'm sure it will be release 6, but has it already passed the 2 releases, or release 5 was the first release? If it has already passed the 2 releases, it can consider to go through the maturity review.
Yeah, so Nodes is basically the part of ICN, right? It's one of the sub-project within ICN. Yeah. So it's already passed through all the, I think it's from R3 or 4, I think.
Yeah, ICN, yes, but I'm not sure about noodles. Yeah.
Oh, yeah.
Yeah. Yeah. I mean, either ICN blueprint under ICN blueprint family or noodles can consider going through the maturity review, because you've seen already like several blueprints pass it, and AI edge machine learning, federated machine learning will be the next one. So I think ICN or noodles will be a very good candidate to go through the maturity review, as long as you have like 2 labs, then to like the logs from 2 labs to prove this blueprint can be deployed anywhere in the world, even it's not from the same company. That means it shows one of the factors of the success, a maturity level of this blueprint.
Sure. Yeah. Cool.
Yeah. Any other comments? Yeah. Thank you for everyone staying for 3 days. We have day 1 attracting more than 1,000 participants, and we got 9.6K likes on the live streaming. And day 2, we meet in Palo Alto. Of day 1, some people also meet in Shenzhen, in YSemi. Day 2, we meet in Palo Alto. Like our meeting room is full of people. People have to standing and overflow to the general area. And day 3, we have Wingsurf, Verizon, and Equinix, Intel, everybody talking here. So we have of course, we have Zoom Bomb. Probably next time we'll do the webinar. That's why we kind of, for anybody we didn't know their name, we just remove them and don't admit them from the waiting room to today's call, and they are now watching. They can only watch from the YouTube live streaming link. I think in general this is still a very successful meeting, and we eventually going through the hybrid mode. I hope one day we can do the full in-person mode for our meetings. Any final remark from any participants? And I would also like to thank the team, Kendall and Jill, the Next Foundation team. You're awesome. You provide this wonderful experience for this our half annual event. So Ike, you want to say something? Yeah.
Yes, Tina, I actually personally, I would like to thank you for actually being so kind to take your time and invite some of the speakers that are authorities in the respective fields, and they have absolutely the latest technology information and a vast experience. Some of them bet right now, as we all see, Nurit, Vint. So it's your personal actually effort and your personal achievement. So thank you so much using your good offices and inviting these people. Very much appreciated, Tina. Very much appreciated.
Yeah.
Thank you so much.
It would have been successful with everybody's support. Cora, Ike, Jeff, Jean, Wenhui, and all of you. This is great. This is team effort. Okay.
Thank you.
Yeah. So with that, if no other business, I would say the 3-day event is adjourned. I look forward to seeing you on next Tuesday's TSC course. Thank you, everyone. Thank you for having us.
Thank you. Bye.
Bye for now.
Thank you, Tina.